For countless generations, the night sky was a source of wonder and mystery. Ancient humans looked up from the warmth of their earthly cradle, gazing at the stars with dreams of gods and heroes. We told stories about those lights in the darkness, not knowing that one day we would venture out among them. The earth was our home, our nursery in the cosmos, a safe haven where humanity was born and grew. But as one visionary observed, the earth is the cradle of humanity, but one cannot live in a cradle forever. And so, with curiosity and courage, we began to take our first tentative steps beyond our home world. It started with fire and metal reaching toward the heavens. In the mid-20th century, our ingenuity and restless spirit forged powerful rockets that could escape Earth's embrace. In a roar of flame, the first slender vehicles leapt skyward, carrying our hopes and aspirations beyond the blue sky. We broke the chains of gravity, if only for minutes at a time. In 1957, a silver sphere called Sputnik rode a pillar of fire into the night and became the first human-made star in the sky. Its faint radio beeps from orbit proclaimed that we had reached space at last. Soon after, other pioneers followed. First, simple machines, and then the brave and curious explorers within them. Imagine the awe of the first human to slip the bonds of Earth. In April 1961, a single man sat atop a towering rocket, heart pounding as engines ignited beneath him. Moments later, he was weightless, peering down at the planet that had always been his entire universe. The gentle arc of Earth's horizon came into view, the clouds and oceans shining against the black void. "I see the Earth. It's so beautiful," he murmured as his spacecraft soared around the globe. For the first time, a human being was out in the cosmic ocean, looking back at our fragile blue cradle. That voyage of Yuri Gagarin, just 108 minutes long, marked a turning point. Humanity was no longer confined to Earth's surface. Each milestone came quickly. A few years later, another explorer opened his hatch and floated freely outside his ship, becoming the first to walk in the void of space itself. He drifted against a backdrop of endless night, tethered to his capsule, proving that we could survive, even briefly, outside the protective cocoon of a spacecraft. We were like infants, pulling ourselves upright for the first time, seeing our wider surroundings with fresh eyes. We sent women and men in tiny capsules, circling the planet, learning how to live without gravity for days at a stretch. With each mission, our confidence grew, and our gaze lifted toward more distant goals. Then, in July 1969, the world watched as humans set foot on the moon. It was a moment at once surreal and sublime. 250,000 miles from home, on a silent grey plain under a black sky, a boot pressed into powdery dust that had never known the touch of life. One small step for a man, one giant leap for mankind, came the calm voice of Neil Armstrong as he descended the ladder and stepped onto lunar soil. In that profound moment, a piece of humanity stood on another world entirely. The astronauts looked up and saw Earth suspended in the sky above the moon's horizon, a blue marble floating in darkness. One astronaut later noted that by raising his arm and holding out a thumb, he could cover the entire Earth behind it. Every person, every ocean, every mountain hidden behind a fingernail. Such was the smallness and delicacy of our world in the cosmic expanse. For those watching back on Earth, seeing our fellow humans walking on that distant orb, it was as if we all had taken that step together. Our species had left its cradle and entered a wider universe. On the moon's desolate surface, we left bootprints and flags, and brought back rocks that told stories of an ancient, alien landscape. We spent only a few fleeting days there at a time, but the significance of those journeys echoed across the globe. Children looked at the moon and knew that people had been there. They could imagine going themselves someday. The barrier between Earth and space had been broken not just by machines, but by living, breathing humans. We had proven that even other heavenly bodies were within our reach if we dared. After the moon landings, our focus turned back to the space around Earth. We built new spacecraft and space stations, learning to live in orbit for longer periods. By the end of the 20th century, humans were living continuously aboard a space station circling high above our planet. From that vantage point, an astronaut could watch a sunrise or sunset every 90 minutes. They floated in microgravity, working, eating, and sleeping in a humming home among the stars. Fragile, but enduring. This was humanity's first real foothold in space, a small habitat orbiting above the world of our birth. Inside that outpost, people from many nations lived and worked side by side, showing that space could unite us in common purpose. These were our first steps, wobbly, uncertain, yet filled with wonder. We had slipped out of the cradle, even if only onto our front porch, as it were. The vast cosmos beyond was still largely untouched, but no longer unreachable. We had looked back on Earth and realized both its beauty and its fragility. Our home was just one tiny oasis in a great dark sea of space. And having taken these initial steps, we felt more strongly than ever the pull of what lay beyond. Beyond the moon, Mars shone as a rust-coloured star in the night sky, beckoning. And closer by, space itself offered new realms to explore. Humanity was ready to venture further, to build and to settle beyond the world that had cradled us for so long. Above our planet, amid the silent vacuum, we began building our first true homes in space. What started as small, cramped stations slowly evolved into vast orbital habitats. Islands in the sky, as dreamers once called them. Imagine drifting outside one of these cities in orbit and looking at it from afar. A great wheel or cylinder rotating against the backdrop of the stars, sunlight glinting off its structure. Within, thousands of people go about their lives. Inside the spinning wheel, there is gravity, artificial, but gentle and familiar, holding inhabitants to the floor. Along the inner rim stretches a landscape crafted by human hands. Green parks and gardens, apartments and laboratories, even small lakes shining under an artificial sky. Huge windows arch overhead, and through them one can see the curve of the earth below, brilliant blue and white, always present in the sky of the colony like a hanging painting. These orbital cities are self-contained worlds. They recycle air and water, grow their own food in aeroponic farms, and draw energy from the sun. In the quiet mornings, residents might stroll through a tree-lined avenue while a dawn of reflected sunlight creeps across the habitat's interior. Not so different from a peaceful morning on Earth. Children laugh and chase each other in playgrounds that overlook the cosmos. In the evenings, some gather by a window to watch the Earth turning slowly beneath them, its clouds swirling over continents. In these moments, they are reminded that though they live in space, they are still tethered to their home by memory and by the pale blue beacon shining through their window. It took decades of effort to reach this level of comfort above the sky. Long before orbital colonies housed families and schools, we tested the waters with smaller outposts. Engineers and astronauts spent years learning how to assemble large structures in microgravity. Module by module, we constructed early space stations, each a little bigger and more complex than the last. At first, only a handful of people could live there at a time, and only for a few months. But over time, we mastered closed life support systems, radiation shielding, and the use of materials from space itself. We learned to mine the void for what we needed, capturing the energy of the sun with wide arrays of solar panels, and even processing lunar soil or asteroidal metals to build and expand our stations. With each innovation, our habitats grew. What began as research labs and observatories gradually transformed into thriving settlements. By pooling resources and knowledge globally, humanity built structures so large and stable that they deserved to be called cities. People began to move there, not just as explorers, but as settlers. Scientists with their families, technicians, teachers, and pioneers from all walks of life. Life in orbit became routine and peaceful, with its own rhythms and culture. Floating between worlds, these citizens of the sky forged a unique existence, surrounded by stars and serenity. While orbital habitats blossomed, we also turned our attention back to the moon, the mysterious neighbour that had beckoned us since antiquity, and where we had briefly visited during Apollo. This time, we came with the intention to stay. In the moon's south polar region, where the sun's rays slant across the horizon and leave some peaks bathed in nearly perpetual light, we established our first lunar outpost. There, at the edge of craters whose depths hide ancient ice, a cluster of pressurized habitats and laboratories clings to the dusty, grey terrain. Silver domes and cylindrical modules are linked by tunnels and covered in protective blankets of moon rock to shield inhabitants from radiation and micrometeors. Solar panels line the ridges nearby, soaking up sunlight that never strays far. Inside the lunar base, men and women live and work in a low-gravity environment where each step is a light bounce and lifting heavy equipment is almost effortless. They must adjust to a day-night cycle that lasts 2 weeks each. Long, cold nights and blinding days, unless they remain at those sunlit peaks where night is brief. In the cozy habitats, astronauts grow leafy greens under LED lights and tend small indoor farms for fresh food. A welcome taste of Earth on an alien world. They venture outside in bulky suits to explore the virgin landscape, driving rovers into the craters to harvest the ice hidden in perpetual shadow. That ice, melted into water, sustains the colony's needs and can even be split into hydrogen and oxygen. the ingredients of rocket fuel. In this way, the moon base slowly becomes a fuel station and workshop for journeys beyond. The inhabitants send robotic miners to scoop up lunar soil, extracting metals and oxygen from the regolith to build radiation shields and more domes. Over time, the outpost expands into a small village of connected habitats. Imagine standing at the center of this settlement during a lunar day. Above, a black sky spangled with stars even at noon, and in that sky hangs the distant Earth, bright and blue, half in sunlight, half in night. The sight is both beautiful and strange. Our familiar home appears small from here, reminding the settlers how far they've come. Life on the moon is not easy, but it is manageable. The low gravity and lack of atmosphere mean that the colonists must remain careful and resourceful. They build underground shelters to retreat during intense solar radiation storms. They learn to repair equipment with limited supplies and to make use of every available resource. The lunar dust clings to their suits and finds its way into habitats, a persistent nuisance that they adapt to with ingenious airlocks and cleaning systems. Over the years, some of the crew rotate back to Earth, while others choose to stay for longer and longer durations, becoming true residents of the moon. A new generation of scientists and explorers grows up knowing the moon not just as a distant light in the night sky, but as their workplace and home. In time, what began as a scientific outpost transforms into a permanent settlement. Perhaps one day, there are even families on the moon, children learning to walk in the gentle gravity, their laughter echoing inside lunar caverns. They would be the first humans to grow up off Earth, citizens of a new frontier. From these early footholds, our cities in orbit and our village on the moon, humanity gained the experience and confidence to push onward. We fueled our ships at lunar depots and built them in orbiting yards. Our eyes turned toward Mars, the red wanderer in the sky that had fired human imagination for centuries. With Earth's immediate neighborhood secured by our presence, we prepared to cross the next great gulf of space. The success of the orbital habitats and the lunar base made one thing clear. We did not have to be bound to Earth alone. We could make our homes wherever we dared to go. And now, one world in particular beckoned to us as the next step. A world that once had running rivers and might still hold the secrets of life. The time had come to journey to Mars, the red frontier, and build a new home on a distant planet. Mars had loomed in our imaginations for centuries, a red dot in the sky that we longed to reach. Now the time had come to make the journey for real. After years of careful preparation, a crew of explorers set forth from Earth, leaving behind the familiarity of home for the allure of the unknown. A sleek interplanetary ship, assembled in orbit and fueled at the moon, carried them across the gulf between worlds. For months, they travelled through the deep, cold vacuum, becoming tiny specks of life in the vastness between planets. They watched as the blue glow of Earth faded into a bright point of light behind them. Ahead, the reddish spark of Mars grew slowly into an ochre disk. Inside the ship, the crew lived day by day in tight quarters, maintaining their vessel, exercising to keep their bodies strong in weightlessness, and gazing out at the stars that no human had ever been so far among. Each passing day carried them millions of kilometers farther from everything they had ever known, and closer to a world that until now had only been visited by our robots and our dreams. At last, the spacecraft neared its destination. The crew peered through viewports at Mars, filling their sight, a stark, rust-coloured globe marbled with wisps of cloud. They could make out the white glow of polar ice caps and the colossal outline of ancient volcanoes on the horizon. The moment of arrival had come. The ship detached a landing craft that began its descent through Mars's thin atmosphere. Orange fire licked the heat shield as the craft sliced downwards. Parachutes blossomed in the sky, breaking the capsule's fall, and retro rockets roared to ease the final drop. Then, with a gentle thump, the module settled onto Martian soil. A new crater of dust billowed, and then slowly fell in the weak gravity. Inside the lander, hearts raced with excitement and relief. Years of planning had come to fruition. One of the explorers spoke into his radio, announcing back to Earth the historic news. Humanity had arrived on Mars. After checking all systems and suiting up, the crew prepared to step outside. The hatch opened to a world no human had ever physically touched. The first explorer descended the ladder, much as Armstrong had done on the Moon decades before. Below was a reddish-brown ground, littered with rocks that had been still for eons until now. She planted her boot into the soft, fine sand and took a few cautious steps. Mars's gravity was only a little over a third of Earth's, enough to keep her anchored, but making each movement feel almost buoyant, as if she were much lighter, because she was. Looking around, she took in an alien panorama. The sky was a butterscotch hue, tinged pink with dust. The sun hung smaller and dimmer than it ever did from Earth, and the daylight felt like a perpetual late afternoon. Jagged hills and dunes stretched out under a copper sky. Far off in the distance, perhaps, rose the slopes of a mountain or the rim of a great crater. Everything was quiet and still. Not even a breeze disturbed the stark beauty of this Martian desert. One by one, the rest of the crew emerged, their white suits contrasting with the ruddy landscape. Standing together on Mars, they felt a profound mix of jubilation and loneliness. They were further from Earth than any humans before, with the whole of space separating them from home. And yet, beneath their excitement was a calm determination. There was work to be done. They intended not just to visit, but to stay and build. In the days and weeks after landing, the crew turned a bare landing site into a fledgling outpost. They deployed habitats that had travelled with them, inflatable living quarters that expanded like great tents, life support systems to produce air and water, and solar panels that unfurled to soak up the feeble Martian sunlight. With teamwork and precision, they connected these modules by flexible tunnels and cables, creating a small but functional base. Inside the habitats, they could remove their helmets and breathe air, enriched with oxygen, recycled from what they brought and extracted from the Martian soil. The first nights on Mars were spent inside these domed shelters, where the explorers found the gravity strange. Objects fell slowly, and walking required a half-bouncing gait. Through small portholes, they watched the unfamiliar sky turn dark, revealing constellations skewed by a new perspective, and two tiny moons, Phobos and Deimos, that sped across the heavens. When Earth rose, it was just a bright, star-like point, a poignant reminder of how far they had come. Life on Mars quickly fell into a routine of discovery and adaptation. Each morning, the crew donned their suits and ventured outside to continue assembling their new home. They set up equipment to harvest Martian resources. Drills bored into the soil in search of water ice hidden beneath the surface. They found some, and soon a steady trickle of water was being filtered and stored, a precious supply for drinking, growing plants, and making fuel. In a small greenhouse module, seeds from Earth were sown in trays of Martian dirt, mixed with nutrient-rich supplements. Green sprouts soon pushed up, the first delicate life to grow in Martian soil under human care. These tiny leaves, unfurling under an LED lamp, symbolized hope, proof that Earth life could put down roots on this alien world. The astronauts tasted their first harvest of leafy greens with delight, a fresh salad grown on Mars, the flavor enlivened by the knowledge of how extraordinary it was. As weeks turned to months, what began as a temporary camp evolved into a more permanent settlement. Additional supply ships arrived, bearing new crews and more equipment. They brought advanced habitat sections, vehicles, and tools, slowly expanding the outpost into a cluster of interconnected domes and shelters. The settlers learned to bake bricks from Martian regolith and began constructing radiation-shielded storage bunkers and garages for their rovers. Solar panel farms spread out across the plain, and experimental nuclear reactors were established to provide reliable power through the long, cold winters and dust storms. The colony, once just a handful of people, grew to dozens, rotating in and out, but always maintaining a continuous human presence. They named their new home, perhaps after a mythic god of fire or a concept of hope, marking the first human settlement on Mars with a proud name. The challenges were immense. Mars was unforgiving, its air too thin to breathe and lacking a protective ozone layer, meaning the sun's radiation was a constant invisible rain. The colonists had to shield themselves well and limit their exposure. The weather could turn suddenly as well. A serene morning might give way to a dust storm, with copper-coloured clouds engulfing the lander and base in fine powder and dimming the skies for days or weeks. During those storms, the sun would fade to a feeble glow, and the solar panels would struggle. The settlers would hunker down, securing everything and relying on backup power and supplies until the dust settled. In the depths of winter, temperatures plunged far below freezing, and even the inside of certain modules rhymed with frost before heaters chased the chill away. The human body too felt the strain. The lower gravity caused muscles to weaken over time and bones to lose density, despite rigorous daily exercise. Each colonist knew that a long stay might mean they could never fully adjust to Earth's heavier gravity again, without great difficulty. In a very real sense, those who stayed a long time were becoming citizens of Mars, physically as well as spiritually. their bodies slowly adapting to the lesser pull. Yet their spirits remained indomitable. They coped with isolation by forming a tight-knit community, celebrating one another's birthdays in the habitat dome with makeshift decorations, sharing recorded music and messages from Earth delayed by minutes of radio travel, and even humor to lighten the long days. At night, in their bunks, some would pen letters or record video journals to send back to family on Earth, reflecting on the surreal fact that they were living on another planet. Between the necessities of survival, the settlers also found time to explore and marvel at their new world. They drove rovers across dusty plains to collect rock samples and study Mars's geology up close. They visited the edge of a great canyon that stretched beyond the horizon, standing on a cliff and gazing into a chasm so vast that the Grand Canyon back on Earth would be just a minor crack in comparison. They climbed partway up the gentle slope of a gigantic volcano's base, marveling that this single mountain could dwarf any ever seen on Earth. Every expedition revealed new vistas, fields of boulders sculpted by ancient floods, hills formed from the ashes of long-extinct volcanoes, and valleys where once, billions of years ago, water flowed freely. Sometimes they would come across odd-looking rocks or patterns in sediment, a ripple frozen in stone, or a whisper of past water chemistry that made them wonder if tiny organisms once lived here in Mars's youth. They collected samples carefully, brought them back to the labs within their base, and peered at them through microscopes, hunting for the faint signatures of ancient life. And in time, their persistence paid off. In a slab of mudstone, a scientist found peculiar microscopic structures, fossilized shapes that looked like the simplest of cells. Further analysis confirmed it. Evidence that microscopic life had once existed on Mars, billions of years ago, when the planet was warmer and wetter. The discovery sent a thrill through the colony and all the way back to Earth. Humanity had proof we were not the only genesis of life in the universe. Life had arisen independently on another world, even if it was only microbes long since turned to dust. In the quiet of the Martian evening, the settlers looked out at the barren land with new eyes, knowing that in some ancient epoch, this place had its own living story. The find deepened their sense of purpose. They were not only pioneers of humanity, but also the custodians of Mars's secrets, uncovering chapters of a story that stretched across worlds. As the years went on, the Mars base grew into a true colony. What started as a handful of habitats became dozens, then perhaps hundreds of modules, some brought from Earth, others manufactured on Mars by robotic factories using local materials. Greenhouses and biodomes multiplied, producing not just vegetables but fruits and grains, and even small trees that converted carbon dioxide into oxygen. The colony became more self-sufficient, needing fewer supply shipments as it learned to live off the land. The population changed too. Some colonists stayed on for years, becoming veterans of Mars life who mentored new arrivals. Eventually, couples formed, and the first children might have been conceived and born on Mars. Imagine the first cries of a baby echoing within a dome on the red planet, the first true Martian human, never having breathed the air of Earth. As that child grows, their bones and muscles develop in Mars's low gravity, perhaps making them taller and leaner than they would be on Earth. And their perspective is entirely Martian. For them, Earth is a beautiful distant light and a place in stories, somewhere their parents came from. Such children of Mars would be a new chapter of humanity, adapted to a new world, bonded to it as their home. Over generations, the people of Mars might even begin to diverge slightly from those on Earth in culture, outlook, and even biology, truly becoming the Martians that Earthlings once only imagined in fiction. The colony endured and thrived through hardships, and in doing so, it changed those who lived there. The boundless determination to make a home out of a desert paid off day by day. Every brick laid, every crop harvested, every scientific breakthrough, each was a step in humanity's journey on Mars. Standing outside the habitat at sunset, a colonist could watch the sky turn a gentle blue-grey at the horizon as the sun dipped low, see the evening star of Earth beginning to twinkle, and feel an immense pride. We were becoming a multi-planet species, turning what was once a distant target of curiosity into a living extension of our civilization. And yet, even as they made themselves at home on Mars, the settlers felt a profound connection back to Earth and to all of humanity. They were pioneers, but they were not alone. They carried the aspirations of billions with them. Mars was no longer just a frontier. It was a community, a place with an ongoing human story. In time, talk in the colony turned to the future. Building a base was one thing. Transforming an entire planet was another. As they looked around at the red plains and pink skies, some of the Martian colonists began to dream even bigger. Perhaps Mars need not remain so inhospitable forever. Perhaps one day, green plants could cover its surface, and fresh air could fill its skies. The idea of terraforming Mars, turning the red planet into a world more like Earth, took root in minds both on Mars and back on Earth. It was an audacious dream, one that would take generations or centuries, and commitment beyond any project humanity had ever attempted. But having come this far, we were not about to shy away from grand visions. If we could walk on Mars and live there, why not try to awaken the sleeping planet, to give it new life? Thus, as the colony stabilized and prospered, the stage was set for the next phase of the adventure. The long, patient work of transforming Mars from red to green and creating a second Earth under the light of an alien sun. Terraforming Mars began as a daring vision and gradually became a monumental endeavor spanning generations. In the beginning, Mars was still a frigid desert where humans could only survive inside sealed habitats or suits. But the colonists and scientists on Mars, together with brilliant minds on Earth, set out to reshape the planet's destiny. They devised plans to give Mars a thicker atmosphere, warmer temperatures, and eventually the gift of liquid water on its surface once more. It was a slow, patient kind of warfare against the cold and the barren, a battle fought with science and ingenuity, aiming to awaken a sleeping world. The early steps were modest but crucial. Teams established automated factories on Mars's surface to pump out potent greenhouse gases, the same kind that on Earth we feared for warming the climate. Here on Mars, those gases were welcomed. Carbon dioxide, methane, and specially engineered compounds began seeping into the thin air, designed to trap the sunlight and raise the planet's temperature. At the same time, enormous mirrors were constructed in orbit, vast reflective sails that could focus additional sunlight onto the Martian poles. When these mirrors unfurled and caught the sun, gentle beams of warmth bathed the polar ice caps, encouraging them to release their hold on frozen carbon dioxide and water. Meanwhile, engineers orchestrated an even more dramatic plan, redirecting icy asteroids and comets from the outer solar system to collide with Mars. Over the course of decades, several small, ice-rich bodies were carefully guided to impact the planet's surface or atmosphere at controlled angles. Each impact delivered a burst of heat and a wealth of water vapor and ammonia, ingredients to thicken the air and seed the skies with clouds. These methods were risky and required precision to avoid catastrophe for the fledgling colonies, but they were executed with great care and remote guidance. The settlers watched from protected shelters as streaks of light crossed the Martian sky, and distant thuds signaled the delivery of cosmic ice. With each effort, bit by bit, Mars began to change. The transformation was not immediate. It unfolded over many years and decades. At first, the differences were slight, a rise of a few degrees in average temperature, a few more days of thin clouds observed in the sky. But these small changes fed into larger ones. As the planet warmed, more carbon dioxide gas sublimated from the polar ice and the soil, further thickening the atmosphere in a helpful cycle. The increased pressure and warmth allowed water to persist longer on the surface when it appeared, instead of instantly freezing or evaporating. The colonists started to notice that the brutally cold nights were a little less cold than before, and the daylight hours a bit more comfortable to work in. They still wore suits outside, but the danger of instant frostbite or asphyxiation was slowly retreating. After some years of concerted effort, there came a historic moment. The first time liquid water was seen flowing on Mars again. Near the colony, trickles of meltwater from a sloping crater rim formed a tiny rivulet after midday sun had warmed a patch of ground. The water soon sank into the thirsty soil, but its brief glisten under the alien sun was an omen of things to come. Encouraged, the terraforming teams pressed forward. They seeded the high atmosphere with substances to encourage cloud formation. Soon, thin, wispy clouds became a common sight, painting strokes of white against the salmon sky. Occasional sprinkles of precipitation fell, though initially they evaporated before touching the ground, a phenomenon the settlers watched with fascination. Ghostly rainfalls that never wetted the soil. Over time, as the air pressure grew, some of those rains began reaching the surface as light showers. People stood outside in their protective suits, arms outstretched, feeling the gentle patter of Martian raindrops on their visors, marveling that such a thing could be happening under what once was an eternally dry sky. Mars was changing from a world of endless drought into one where water could exist openly, at least in some places and times. Dark streaks on crater walls hinted at seasonal flows. Patches of ground turned a darker hue after rare rains. In newly formed ponds near the poles, scientists introduced hardy algae and cyanobacteria, microorganisms engineered to withstand Mars's still thin air and cold nights. These primitive life forms took hold in the mineral-rich water and began producing oxygen through photosynthesis. They were the pioneers of an ecological foothold, slowly preparing the way for more complex plants. Years later, in areas where the climate had become milder, test plots of moss and lichens were coaxed to grow on rocks under the open sky, surviving the still harsh winters and spreading a faint green tinge across patches of red ground when spring came. Decades turned into centuries. Each new generation on Mars built upon the work of the previous, never seeing the final result themselves, but inspired by the gradual improvements they did witness. The atmosphere grew thicker and more Earth-like with each passing era. From orbit, the planet's colour shifted subtly, still predominantly rusty red and ochre, but now with swirls of white cloud and darkened patches that hinted at moisture and burgeoning life. With a denser atmosphere came a remarkable sight, something no human had ever seen on Mars before. Open water shimmering in the sunlight. Perhaps it began with a single lake in a low basin, fed by melting ground ice and modest rainfall, its surface ruffled by the first Martian breeze, strong enough to be felt. Over time, rivers that had been dry for eons filled anew with seasonal snowmelt from rejuvenated polar caps. Ancient lake beds became lakes again. A shallow sea spread across parts of the northern plains, where long ago an ocean might have been, its waters reflecting the pale daylight. At the shores of these new lakes, imported reeds and hardy aquatic plants took root, greening the edges with life. As Mars warmed and moistened, the colonists ventured outside their domes with lighter gear. Where once stepping out unprotected meant certain death, now the air was dense enough to slow boil water, and temperatures in some regions hovered around the freezing point or above during the summer months. Still too cold and thin to breathe unaided, but vastly improved. In some low-lying, well-terraformed areas, engineers built large open biodomes, valley-sized enclosures where earth plants could be grown in near-outdoor conditions. Inside these vast greenhouses, trees and crops flourished in Martian soil under filtered sunshine, giving a glimpse of what a fully terraformed Mars could one day look like. Outside, the sky had shifted from its former butterscotch to more of a pale blue during the day, especially when dust was low, still paler than Earth's sky, but recognizably closer to home. Sunrises and sunsets painted the heavens in deep indigo and gold, with whirls of clouds catching the light. The ultimate goal was a Mars where humans could walk freely without a breathing mask. But that goal was still distant. Producing enough oxygen for a breathable atmosphere was the slowest step, requiring either millennia of plant activity or massive technological intervention on a scale yet out of reach. Nonetheless, progress was visible and accelerating. Perhaps a few generations into the terraforming project, a milestone was reached. Children born on Mars could go outside with just simple breathing gear and no full pressure suit, at least during mild weather. They could feel the soil of their planet under their boot, without a thick layer of fabric in between, and feel a breeze on their face if they cracked their helmet visors for a moment. It is thin and cold, but it is real air. They giggle and put their masks back, knowing that one day, in their lifetime, or their children's, those masks might not be needed at all. With each passing decade, the need for domed habitats shrank. Settlers began constructing towns in the open air, at first in areas specially chosen for their hospitable conditions, deep valleys that held thicker air, near newly formed bodies of water. They built homes with sturdy walls and heating for cold nights, but they could step outside those homes into the Martian dawn, wearing only a light environment suit, akin to a warm jacket and an oxygen mask. They planted terraced gardens on hillsides under the open sky, protected by little more than windbreaks and clever frost shelters. Pine-like trees, bioengineered to tolerate high carbon dioxide and cold, were seeded across emerging fertile patches. Many failed, but some took root, and over decades grew into strange groves. Martian forests, sparse but hardy, with leaves of deep purple or black to better absorb the weak sunlight. These groves further pumped oxygen into the air and provided shelter for other species to grow beneath. Imagine an observer centuries after the first colonists landed. They stand on a hillside overlooking a broad Martian valley. The ground at their feet is covered in a dry grass-like plant that sways in a cool breeze. Down in the valley, a ribbon of water, an actual flowing river, glints in the sunlight, winding its way toward a blue horizon where a great northern sea reflects the sky. Scattered clouds drift overhead, occasionally showering the land with gentle rain. In the distance, the silhouettes of human dwellings are visible, houses and domes among fields that have begun to tame the wild Martian landscape. Children are running and laughing along the riverbank without spacesuits, perhaps wearing only small respirator devices, while their lungs slowly adapt to the still thin air. One child pauses, and, in a moment of boldness, lifts the mask from her face. She takes a tentative breath of the Martian air, still rich in carbon dioxide, but carrying a detectable hint of oxygen. It is thin and cold, but it is real air. She giggles and puts her mask back on, knowing that one day that mask might not be needed at all. The red planet is turning green. From orbit, future travelers see patches of emerald and turquoise on the surface, where once there were only shades of red and brown. Mars has become a world of rust-coloured deserts, punctuated by blue lakes and struggling forests. A world that is coming alive. By the time the terraforming project reaches its later stages, the planet supports a self-sustaining ecosystem. In the wetlands of a new Martian sea, algae and aquatic insects thrive. Along the emerging creeks and oases, hardy shrubs and grasses spread seeds each season. Birds and mammals from Earth have not yet been introduced. Such complex life will likely wait until the atmosphere is more hospitable. But perhaps small experimental populations of genetically adapted insects or amphibians are set free to test the waters. Literally, the sound of a cricket chirping under a Martian night, or the sight of a small fish darting in a Martian spring-fed pond, are marvels that bring tears to the eyes of those who witness them. Each is a note in the symphony of revival playing out on this once silent world. Terraforming Mars is an act of creation and responsibility. The people of Mars, who now consider the planet their home as much as any nation on Earth ever was to its inhabitants, feel a deep pride in what they have accomplished. The labour of their great-grandparents allows them to walk on soil that yields food and to breathe air that, while still supplemented by tanks, grows richer every year. They give names to the rivers and lakes, christening them after figures from Martian mythology and the scientists who paved the way. They protect regions of historical importance, like the landing sites of the first missions and the areas where the fossils of ancient Martian life were found, making sure these are preserved even as the environment changes around them. In those preserved crimson pockets, one can see what Mars was like before and appreciate how profound the change has been. Standing on a hill under a twilight sky that now alternates between Earth-like blues and Martian reds, a group of Martian humans might watch the evening star of Earth appear. For so long, Earth was the only cradle of life. Now, thanks to their efforts, life has not just left the cradle, it has carried the cradle's nurturing essence to a new world and planted it there. Mars, once a symbol of barrenness and war, has become a symbol of renewal and hope. A planet that was effectively dead for billions of years now breathes with a new, tenuous life. There is grass on the dunes, rain in the forecast, and humanity walks freely on two planets. The success on Mars begs an even larger question. If we can bring life to Mars, where else might we go? By turning the red planet green, we proved that even the most desolate places can be made habitable with enough time and determination. Mars was our second home, born of science and sweat and dreams. And as it bloomed, our eyes naturally drifted farther outward, toward the asteroid belt and the giant planets and their moons, places even more forbidding than Mars once was. But with Mars transformed and thriving, we gained the confidence to reach those distant outposts and to extend this human adventure to every corner of our solar system. By the time Mars was blossoming with new life, humanity's reach extended to even more remote corners of the solar system. The asteroid belt, a vast ring of tumbling rocks between Mars and Jupiter, became our next frontier. What once were seen as mere lifeless boulders drifting in space were now treasure troves of raw materials and potential stepping stones to the outer worlds. Spacefarers established bases on and inside these asteroids, creating some of the most unusual homes humans have ever known. On one such asteroid, a mountain-sized shard of rock softly turning in the sunlight, a mining outpost was carved directly into the stone. Within its hollowed core, astronauts and engineers built living quarters and laboratories, using the asteroid itself as a protective womb. They spun the rock slowly with powerful engines, just enough to generate a gentle artificial gravity along its inner walls. The result was a hidden sanctuary, a cavernous space where, under the vaulted ceiling of native stone, people walked about in shirt-sleeve uniforms, breathing air held in by pressure seals, with an entire asteroid shielding them from cosmic radiation. Gardens of algae tanks and hydroponic vegetables lined the carved corridors, illuminated by lamps powered by solar collectors on the asteroid's sunward side. Outside, robotic drills and diggers chipped away at the regolith, extracting iron, nickel, water ice, and rare metals that had once been locked up since the birth of the solar system. These materials were shipped off to orbiting factories or used right on site to expand the habitat. In the quiet moments, a miner could step out of an airlock in a pressurized suit and stand on the surface of that asteroid, gazing out. Because the gravity was so weak, they could strap on a pair of mechanical wings or small thrusters and leap gently off the rock, floating above its pitted landscape as if in slow motion. The stars around were unblinking and sharp, and the sun, now more distant than from Earth, shone a bit smaller, but still brilliantly. In the distance, they might see the faint glimmer of Jupiter, or the far-off glint of Mars. To live on an asteroid was to experience space in its raw intimacy. There was no thick atmosphere or strong gravity to buffer you, just your suit, your habitat, and the endless night. It was both eerie and awe-inspiring. Dozens of asteroids eventually hosted human activity. Some became specialized mining stations, supplying precious resources to the rest of humanity's colonies. Water, mined from ancient ice within those rocks, was converted to rocket fuel and shipped to depots orbiting planets, enabling further exploration. Other asteroids were turned into research stations, astronomical observatories far from Earth's light and noise, where scientists could study the universe with crystal clarity. A few particularly large asteroids, like Ceres, dwarf planet and queen of the belt, grew into hubs of commerce and travel. At Ceres, with its weak but present gravity, settlers built a domed city inside a giant crater. Beneath an enormous transparent dome, they cultivated gardens and built dwellings, all bathed in an artificial day-night cycle by lamps on tall towers. Outside the dome, Ceres' surface remained as airless and silent as ever, but inside, a small bustling town thrived, complete with marketplaces, schools, and hospitals. Travellers, stopping over on their way to Jupiter or returning from Mars, could refresh themselves in this quiet worldlet, drinking water drawn from the Cererian subsurface aquifers and eating food grown under the dome's glass. The people there called themselves Children of the Belt, a nod to the fact that they lived not on any planet or moon, but on a minor world that had become their beloved home. Beyond the asteroid belt, the giant planets beckoned. Jupiter, the colossal gas giant with its whirling storms, and Saturn, adorned with ethereal rings, had long been observed by telescopes and visited by robots. Now, at last, human beings would venture into their realms, not as brief explorers, but as settlers, establishing outposts in the harshest environments yet faced. Reaching Jupiter was an odyssey in itself. The journey was far, the radiation intense, and the environment completely alien. But advanced spacecraft with fusion-powered engines made the trip faster, and years of experience in radiation shielding and life support prepared crews for the dangers. They arrived not to step out onto Jupiter itself, a gaseous world with no solid ground, but to its family of moons, each a world of wonders. On the moon Callisto, one of Jupiter's large Galilean moons and the furthest from the planet, humans found an ideal beachhead. Callisto was cold and covered in ancient craters, but crucially, it lay outside Jupiter's fiercest radiation belts. A landing base was established on its icy surface. The settlers built habitats partially underground for insulation and radiation protection, using Callisto's own ice and rock as building material. From Callisto's sky, Jupiter loomed large, but not as dangerously close as from the inner moons, providing a magnificent view of swirling cloud bands and the Great Red Spot, a constant reminder of the Titan that dominated this system. As the base grew, Callisto became a gateway for exploration of Jupiter's system, a safe haven where ships could refuel and crews could recuperate. From bases like the one on Callisto, humanity reached inward to the more challenging Jovian moons. They sent expeditions to Ganymede, the largest moon in the solar system, which intriguingly had its own magnetic field and a mix of ice and rock. There they established another outpost, both for studying the moon's unique properties and as a stepping stone closer to Jupiter. But perhaps the most daring endeavour was on the moon Europa. Europa had tantalized scientists for over a century with its smooth, icy surface and the strong evidence that beneath that ice lay a global ocean of liquid water kept warm by tidal energy. Where there is water and warmth, there might be life. Thus, setting foot on Europa was not only about colonization, but about discovery. A small cadre of scientists and engineers set up a camp on Europa's surface, near the equator, where the ice was thick but relatively stable. They lived in a cluster of modules anchored to the ice, careful to avoid regions with too many cracks or chances of geysers erupting. The European sky was dominated by Jupiter, huge and brilliant, illuminating the ice in an otherworldly glow. Each day, if one could call the 3.5 Earth day rotation a day, the colonists dealt with intense radiation and the challenges of being on a world that was essentially a floating shell over an ocean. They wore radiation-hardened suits when venturing outside and kept missions brief. The great goal here was to explore the ocean below. Using a powerful heated drill and a nuclear-powered melting probe, they carefully bored a shaft through miles of ice, a task that took months of continuous effort. When the probe finally broke through into the liquid water below, it released a submersible robotic vessel equipped with lights and cameras. The colonists crowded around monitors in their habitat as the drone swam into European depths, becoming the first eyes to behold that alien sea. In the darkness, beneath the ice ceiling, the probe's lights revealed a world that had never seen the sun. Perhaps strange mineral formations, vents spewing warm, mineral-rich water from the moon's core, and, astonishingly, signs of life. Clinging to the rocks around these hydrothermal vents were mats of microorganisms, and maybe small, ghostly creatures akin to tube worms or shrimp-like beings, thriving in the warmth and chemical energy. The moment that camera caught the first flutter of a European creature, a chill and then a cheer went through the tiny team on the surface. We had found living alien life, no longer just fossil remnants as on Mars, but life active in its own alien ecosystem. Though simple and mindless, these organisms proved that life could take hold beyond Earth in the most unexpected of niches. The colonists took careful samples via their robotic submersible. Knowing such discoveries carried immense significance. They left most of that hidden biosphere untouched, as a protected treasure for science, and sealed up the drill hole to prevent contamination. Europa remained largely a place of scientific pilgrimage, a research station on the edge of an alien abyss. But even so, it expanded humanity's presence and sense of connectedness with the cosmos. Under the glow of Jupiter, humans walked on Europa's ice and knew they were not alone in a biological sense. Life had sprouted independently here as well. Venturing further out, Saturn's system offered its own rich destinations. Chief among them was Titan, Saturn's largest moon, shrouded in a thick golden atmosphere. Titan had beckoned as a place eerily reminiscent of a primordial Earth, with thick air, weather, rivers, and lakes of liquid methane and ethane, and a chemistry that might yield life given time and perhaps some tweaks. Human explorers descended through Titan's orange skies in winged craft, designed to navigate the dense atmosphere. The approach to Titan was like coming in for a landing on a hazy twilight world. The sunlight was feeble, just 1% of what Earth receives, so a perpetual dim amber light bathed the landscape. As they broke through the cloud cover, the crews saw beneath them a panorama that no other moon offers. Coastlines and lakes, dunes and flowing channels, all laid out in shades of deep brown and orange. They landed near the shore of one of Titan's great hydrocarbon seas, a body named Kraken Mare, which stretched to the horizon like a mirror of dark glass. Life on Titan was in many ways the opposite of life on Mars or the Moon. Here the air was thick enough to breathe if it had oxygen, though it didn't, and the pressure felt like being slightly underwater back on Earth. A person stepping out onto Titan's surface needed no pressurized suit, only insulation against the extreme cold and an oxygen supply. The settlers wore warm, electrically heated suits to stave off the chill of 180 to go, 292 to go, and carried tanks of air to breathe, but they could move with ease in the dense atmosphere. In fact, moving was unexpectedly joyful. Titan's gravity is low, just 1/7 of Earth's, and the thick air provides buoyancy and lift. With a simple set of wings attached to their arms, or a strap-on glider, a human on Titan could literally fly by, flapping or running and leaping into the air. Some of the early pioneers did just that for sport and for exploration, donning bird-like wings and taking off into the orange skies, powered by their own muscles and Titan's accommodating air. They soared above methane lakes and rugged hills like dreamers in low-gravity flight, something impossible on any other known world. Their laughter and whoops of delight crackled over the radio as others on the ground watched their silhouettes against the dim, hazy sun. The Titan colony built itself gradually. They set up domed habitats on high plateaus to avoid the liquid methane floods that could come with changing seasons. Inside heated greenhouses, they attempted to grow earth plants under spectrum-adjusted lamps, though this proved challenging so far from the sun. Energy on Titan came from a combination of nuclear reactors and the potential chemical energy of the moon's own hydrocarbons. Factories were established to refine the liquid methane and ethane from Titan's lakes into fuels that could be used by colony machinery or future spacecraft. Over time, what started as a single landing outpost grew into a network of Titanian settlements connected by hardy dirigibles. Massive airships, cruising slowly through the murky sky, ferrying people and supplies than any ground rover could over Titan's icy, carbon slush terrain. The sight of a giant balloon airship emerging from the clouds and mooring near the colony became a symbol of Titan's frontier, a fusion of old-world transport and otherworldly environment. Titan's explorers also sought signs of any exotic life that might exist in its methane lakes or soil. Titan's chemistry was so cold and alien that many doubted life as we know it could exist there. So far, no clear evidence of life was found in Titan's lakes. If it existed, it might be exceedingly slow or hidden. But the mere presence of complex organic chemistry everywhere on Titan hinted that the line between living and non-living could blur in these conditions. Researchers set up labs to study Titan's atmosphere and surface composition, hoping to learn how chemistry becomes biology. Even without native life, Titan offered a home for human life and a laboratory for understanding life's possibilities. Elsewhere in Saturn's domain, humans touched smaller moons. A tiny outpost on Enceladus studied its water geysers shooting into space, collecting samples in hopes of detecting organic molecules or microbes from that moon's subsurface sea, an echo of the Europa mission. On Iapetus, with its stark two-toned surface of bright ice and dark dust, a telescope array was built on the ridge of its enormous equatorial mountain range, perhaps the strangest observatory location, perched on a ridge that circles an entire moon. The scientists there enjoyed a view of Saturn's rings, like a jewel-studded arch across the black sky. At times, looking up from the outer moons, the sun was no more than a very bright star, reminding everyone just how far they had journeyed from the warmth of the cradle. And still, humanity did not stop. Pushing beyond Saturn, expeditions reached Uranus and Neptune, ice giants where colonization was limited to orbital stations and labs on their frosty moons like Triton, where geysers of nitrogen spouted and a thin atmosphere hinted at active geology. These outposts were more sparse and rotated crews infrequently, given the great distance. A scientific base on Triton watched the distant sun and studied Neptune's blue visage, content in its solitude on the solar system's frontier. Some adventurous souls even ventured to dwarf planets in the Kuiper Belt, a small research habitat on Pluto's moon, Charon, for example, made history as the farthest inhabited human structure from Earth at that time, where the sun was just an especially bright star, and the Milky Way's glow provided an eerie light over Pluto's icy plains. Life at such extremes was difficult and lonely, but profoundly tranquil. One could stand on Charon's surface and feel like the universe's edge was at their doorstep. By establishing these distant outposts, humanity became a presence on nearly every class of world around our sun. Inner rocky planets, moons of giants, tiny asteroids, and far-flung ice balls. Each new habitat taught us more about living in novel environments and about the creativity required to survive and thrive. The people who chose to live on these frontiers were explorers at heart, but also builders of communities. Whether mining under the crust of an asteroid, diving beneath the ice of Europa, or flying in Titan's golden skies, they all shared something fundamental with those first astronauts who left Earth: a sense of wonder and determination. Living scattered across the solar system also changed humanity's perspective. With people residing on so many different worlds, human became a more cosmopolitan term than ever. A family on Earth could have relatives working on the Moon, cousins living in an orbital habitat near Mars, and perhaps a brother on a science team at Jupiter. Messages and video calls linked these interplanetary families, albeit delayed by the vast distances. Festivals and traditions from Earth were carried to every settlement, often adapted to local conditions. Imagine a midwinter celebration in a sunless European lab, or a new first snowfall holiday on Mars to mark the first time it ever snowed, water snow, on that planet. Human culture grew richer with these off-world threads, each colony developing its own quirks and customs in response to their environment. Yet, across light hours of distance, they all shared roots in the cradle of Earth and common dreams for the future. No longer confined to one planet, humanity had proven that we could spread life to the most unlikely places and flourish there. But perhaps one of the greatest realizations was that even all these planets, moons, and asteroids were not enough to satisfy our species' curiosity and capacity. We began to acknowledge that we need not always adapt ourselves to fit a world. We could adapt the environment or even create new habitats, whole cloth. The success of those asteroid colonies, turning space rocks into living space, hinted at a broader idea: building our own habitats and megastructures, unrestricted by the shapes of natural worlds. If we could mine an asteroid and build a dome on Ceres, why not construct entire rotating cities in free space, larger and more splendid than any planetary colony? Why not capture the very energy of the sun with colossal machines? The only limits were our imagination and our will. Thus, even as the outermost outposts like Titan and Triton were being settled, plans were already unfolding for humanity's next chapter, creating worlds of our own design, greater and grander than nature had provided. The era of the space habitats and megastructures was dawning, an age where humanity would become not just residents of existing worlds, but architects of entirely new ones amid the stars. Humanity's inventiveness reached a crescendo in the age of space habitats and megastructures. Unshackled from the surfaces of natural planets and moons, we turned our engineering prowess to crafting whole worlds in the void. The dreams that early visionaries had imagined, enormous cities rotating in space, artificial suns and engineered planets, now moved from fantasy to reality. It began with habitats built from the spoils of the asteroid mines and the wisdom gained from smaller orbital stations. If an asteroid could be hollowed into a home, we thought, why not build something even larger and more refined? In various stable orbits and Lagrange points throughout the solar system, construction cranes and autonomous drones pieced together titanic structures. One of the first of these true mega-habitats was a cylindrical colony, free-floating in space. A realization of a design proposed centuries earlier, but never feasible until now. This colony was a pair of cylinders, each many kilometers in length and a few kilometers in diameter, slowly rotating about their long axes to provide a comfortable gravity-like pull along their inner surfaces. They were constructed from bonded metals and composites refined from asteroid ore, their walls meters thick to hold in air and block radiation. From the outside, each cylinder glinted like a metallic comet, sunlight gleaming off vast movable mirrors that were arranged around it. These mirrors could be angled to direct sunlight through long ribbon-like windows running the length of the cylinder. From one end, you might see the cylinders gently turning and occasionally catch the sparkle of water flowing in rivers inside, visible when the great windows aligned with your view. It is from within that the true wonder reveals itself. Imagine stepping inside this rotating megastructure. You enter through an airlock and emerge onto what appears at first to be normal ground. A grassy field, perhaps, near a village square. The gravity feels nearly Earth normal under your feet due to the rotation. But when you look up, you do not see a sky in the usual sense. Instead, you see the interior of your world curving up and over you, wrapping around in a full circle. The cylinder's inner surface is a landscape that arches overhead, several kilometers across from where you stand. On the opposite inner curve of the cylinder, there are other fields, forests, and towns, upside down from your perspective, yet held firmly to their own ground by the centrifugal effect. A river might be flowing along, disappearing up into the distance as if climbing the heavens, when in fact it's simply following the inner curve. The far end of the cylinder, many kilometers away, is covered by a massive circular window that, with a system of mirrors, allows sunlight to pour in when needed. Right now, those mirrors might be partially closed to create an artificial dusk. Lights are coming on in the houses of a town curving above you, their glow dotting what looks like a low, arching sky. Birds fly across the cylinder's span, perhaps migrating from one end to the other. And from your vantage, they seem to fly upside down as they cross the midpoint overhead. You can hear the faint echo of thunder from a scheduled rainstorm in a sector far around the cylinder's curve. Yes, even rain and clouds are carefully maintained within this immense tube to water the crops and keep the air fresh. In every direction, there is green land or sparkling water. Some sections are farmland laid out in neat terraces. Others are wild parks with lakes and trails. There are city blocks with buildings that rise a few stories tall, cozy against the curvature of the ground. Standing here, you are in a self-contained world, an island of life floating in space, complete with its own miniature biosphere and weather patterns. These rotating habitats became a cornerstone of human expansion. Unlike planets, they could be built wherever we needed or wanted them, orbiting Earth or Mars, placed at Lagrange points where gravitational forces balanced out to create stable parking spots, or even set adrift in independent orbits around the Sun. Some were built near the inner planets to house growing populations and industry. Others were positioned to support the outer colonies, providing a taste of Earth-like living, even in the far cold regions. Each habitat was an engineering marvel and a work of art, a fusion of technology and nature. They had seasons and day-night cycles regulated by the angling of their mirrors and window shutters. Many habitats maintained a 24-hour cycle simply because it was comfortable for humans, while some tweaked their days to slightly different lengths just to see if human communities could adapt to, say, a 30-hour cycle in a cylinder orbiting Saturn. In those ones, visitors from Earth might feel a bit disoriented at first, at the slower pace of sunrise and sunset. Over time, these space habitats grew in size and ambition. Early ones might hold tens of thousands of inhabitants in relative comfort, but later designs, true megastructures, were vast enough to accommodate millions. We built Stanford-like Tory, giant wheel habitats that spun lazily with gleaming spokes connecting to a central hub where spacecraft could dock. We built Bernal spheres, enormous hollow globes with cities on their inner walls. But the cylinders remained the grandest. In pairs and clusters, they were positioned, rotating in opposite directions to cancel out any gyroscopic effects and keep themselves steady. A pair of cylinders might counter-rotate, joined by a lattice of trusses, looking like a dumbbell in space. People began giving these habitats evocative names: Elysium, New Eden, Sil 1, Tranquility, and even nation-like identities. Indeed, each large habitat became akin to a city-state or a country, with thousands of inhabitants forging a unique culture in their spinning world. Some habitats favoured wide-open, pastoral designs, essentially space farming communities. Others cultivated the bustle of city life, with high-rise structures and enclosed multi-level environments inside the shell. In these habitats, humanity truly learned to live off-world, not as explorers or survivors, but as normal citizens. Generations grew up who had never set foot on natural soil under an open sky, yet they ran through grassy fields and swam in lakes under an engineered firmament. They had their own sports, some adapted to the peculiarities of living in a cylinder. Imagine a form of long-distance running where athletes literally run in a loop around the interior, eventually returning to their starting point from above. Or a game of baseball, where a ball hit too high might literally go into orbit within the cylinder and come back around from behind. The people of these free-floating worlds were as human as any, but their perspective was broadened by living in a place where the cosmos was just outside a thin wall, and where Earth was sometimes a distant memory or a vacation spot. Earth, in fact, benefited immensely from this diffusion of humanity. As industries moved to space, extracting materials from asteroids and soaking up solar energy with no pollution to terrestrial skies or rivers, the Earth itself began to heal from centuries of exploitation. Much of the heavy manufacturing that once burdened Earth's environment was relocated to orbital factories, powered by the sun and supplied by meteoric metals. With abundant resources and energy available off-world, there was less need to mine Earth so intensively or burn fossil fuels. Over the decades, Earth's cities became greener, its air cleaner. Protected by international commitment, vast areas of Earth were rewilded into parks and nature reserves, cherished as the birthplace of us all. Earth became the cherished garden and cultural heart, while the bulk of the mechanical labour and resource gathering occurred in the heavens above. Many people still chose to live on Earth. After all, it was the original paradise with its open oceans and rich biosphere. But they now had the choice to venture outward without pressure on Earth's ecosystem. Earth turned into a kind of revered homeland, the way an ancestral village might be regarded, as humanity's many children built new homes across the solar system. With near-limitless solar energy and materials at our disposal, our megastructures became even more ambitious. Networks of power satellites were assembled to beam clean energy to planets and colonies, ensuring that even the farthest outposts had ample power. Orbiting mirrors were arranged to illuminate dark corners of moons where sunlight never reached, bringing light to shadowed craters on the Moon and Mercury to tap their ice. We constructed solar farms closer to the sun, where swarms of automated stations collected sunlight and transmitted it in beams to wherever it was needed. A concept that grew and grew until it reached its ultimate expression. That ultimate expression was the idea of enclosing our star itself in a web of technology to capture as much of its energy output as possible. What began as scattered swarms of power stations gradually multiplied into a grander construct, often imagined by scientists. A Dyson swarm, sometimes romantically called a Dyson sphere, though it was not a single solid shell, but a myriad of captors. Over centuries, tens of thousands of immense solar collectors and habitat stations were deployed in orbits all around the Sun at various distances, linked in a complex dance to avoid collisions and shadowing each other. From afar, this swarm of structures would shimmer like a cloud around the Sun, catching a significant fraction of its rays. If one could view it from outside the solar system, perhaps our star would appear a bit dimmer, or its light slightly unusual, betraying the presence of our engineering to any distant observer. Within our system, the Dyson swarm provided unfathomable energy, enough to power projects as grand as planet engineering and to support trillions of lives in habitats circling the Sun. The excess energy was beamed as needed to various settlements. A colony in the outer system could harvest a tight beam of sunlight sent its way by an array of aligned mirrors, turning night into day when necessary, or fueling its reactors and life support. As our capabilities grew, so did our sense of collective achievement. We had taken the raw materials of creation, rock, metal, ice, sunlight, and woven them into habitable tapestries. We were no longer passive inhabitants of a single world. We were the gardeners of many worlds, and even the creators of new ones. The distinction between natural and artificial blurred. A child born in a cylinder habitat might feel that world as natural, and view a planet like Jupiter or Saturn through a window as the strange outside. In the megastructures, life went on in comfortable simulation of Earth, but always with the knowledge that it was human-made. This gave people a sense of responsibility and empowerment. If our worlds were crafted by us, then maintaining them, ensuring they remained livable and balanced, was squarely in our hands. We became careful stewards of our creations, applying all the wisdom we had learned from tending Earth and terraforming Mars to maintain these habitats' ecologies. There were occasional challenges, perhaps an ecosystem imbalance causing a pest bloom in one habitat, or a mirror malfunction that altered a day length unexpectedly. But teams of engineers and biologists managed these hiccups, and communities adapted with remarkable resilience. And so, the solar system in time became filled with the fingerprints of humanity. In orbit around the Sun were countless habitats, some orbiting close, shining in the solar glow, others trailing far out, and many stationed around planets where they served as additional living space or support for surface colonies. It was as if 1 billion tiny Earths had sprung into existence, each with air, water, and life, where once there was none. Megastructures also included marvels of transportation and communication. High-speed transport rings that could fling ships at tremendous speeds from one planet to another, or the creation of artificial wormhole gates, if physics allowed such things, as some hoped late in this era, to shorten travel times. On Earth and other planets, space elevators rose toward the heavens, a thin but strong tether, thousands of kilometers long, anchored on one end to the ground at the equator, and on the other to a counterweight in space. Along these ribbons, electromagnetic lift vehicles ferried people and cargo up and down, making the journey from Earth's surface to orbit as gentle as a train ride. The first time a space elevator was built on Earth, it was heralded as the stairway to the stars, and pilgrims travelled from all over the world to watch the ribbon stretch into the sky, and perhaps to take the elevator ride, ascending through clouds and into the blackness in a matter of hours, fulfilling a dream of effortless access to space. It was a golden era of building and exploration. The creative spirit of humanity seemed to know no bounds now that survival was less in question. Art, science, and philosophy flourished in these diverse locales. In a giant sphere habitat, orbiting where Mars once did, a grand concert might be held with musicians from dozens of planets and colonies convening, the music broadcasting across space to every settlement with hardly any delay. In a cylinder at Saturn's orbit, farmers cultivated new strains of crops adapted to low light, contributing to genetic knowledge that helped feed trillions. Knowledge was shared nearly instantaneously via a light-speed communication network that webbed the system, though for the outermost reaches there was still a perceptible delay, which made people appreciate the vast scale of their domain. And as we built ever more impressive monuments to our ingenuity, we also began to cast our view beyond the solar system with renewed intensity. For as much as our sun's neighbourhood now teemed with life and human activity, the stars beyond remained as mysterious and tantalizing as they had been to our distant ancestors. We had answered one ancient question by finding life in places like Mars's past and Europa's ocean. Life was possible beyond Earth. But another profound question remained. Was there other intelligent life out there among the stars? Were we the only ones building cities and megastructures? Or were there others whose lights just hadn't reached us yet? With the power at our disposal, energy enough to send ships to other stars, knowledge to potentially terraform other worlds, we felt ready to attempt voyages beyond our solar cradle. We had become the masters of our own system, but the cosmos is almost infinitely vast. The nearest stars, each a sun with its own retinue of planets, beckoned in our telescopes. Maybe some of those planets were like our Earth, ripe with life, or even civilizations. Or perhaps they were empty, awaiting the touch of life we could bring. The megastructures we built not only gave us the means, but also the motivation to reach further. Some of our habitats were built as generation ships in themselves, capable of being nudged out of orbit and set on interstellar trajectories, carrying entire communities on voyages that might last centuries. And with our Dyson swarm, we had energy to spare to attempt bold experiments in propulsion, antimatter drives, solar sails pushed by immense laser beams, or even theoretical warp engines. Humanity has emerged from its cradle and populated the solar system, even learning to shape entire worlds to its will. And yet, above us, the countless stars still beckon. Having transformed our cosmic backyard, we now stand poised on the edge of interstellar darkness, ready to step into the great beyond. The cosmic ocean stretches out before us, filled with mysteries and perhaps other voices. Our journey through space colonies has been wondrous, but beyond the fringes of our sun's domain, far greater adventures await. Out among the distant stars, new frontiers, and maybe new companions lie undiscovered. Humanity's story in the cosmos is only beginning. Beyond the warm and familiar glow of our sun, a great darkness stretches out, a silent cosmic ocean studded with distant lights. For generations, we have gazed up at those stars from the cradle of our solar system, wondering what lies beyond. Now, as our footprints fade on the dusty worlds orbiting our sun, humanity turns its sights to the infinite night, ready to chart a course to the stars. Leaving the embrace of our sun is no small step. As we venture outward, the pull of home weakens and the distances expand to the truly unimaginable. The planets we once thought were far, worlds like Jupiter and Pluto, now seem like mere stepping stones, barely an inch away on the cosmic map. Beyond them, beyond even the icy swarm of comets at the edge of our solar system, lies interstellar space, a realm so vast and empty that it defies comprehension. In this void between the stars, there is no up or down, no day or night, only the faint glow of far-off suns, each a lonely beacon in a lightless sea. The closest of these beacons, Proxima Centauri, is over 4 light-years away. To us, 4 light-years is a number hard to picture. It is about 40 trillion kilometers, a distance so great that even light itself, the fastest thing in the universe, takes more than 4 years to cross it. Our fastest spacecraft, the brave little Voyager 1, has been racing away from Earth for nearly half a century, and yet, in all that time, it has only just left the sun's protective bubble. If Voyager were pointed at Proxima Centauri, it would drift in the darkness for over 70,000 years before coming close. 70,000 years ago, our ancestors were painting on cave walls by firelight. That is the timescale of the stars. And yet, those distant suns call to us. They stir something deep within, the same restlessness that drove our forebears across oceans and unknown lands. We have always been explorers. When the horizon promised something beyond, we found a way to reach it. Now the horizon has expanded beyond our solar system, and the call of the unknown is as strong as ever. To answer that call, we must become the navigators of interstellar space. But how do you chart a course to something so distant that our maps must measure time in years of light? First, we must choose a destination among the myriad stars. We peer through powerful telescopes, searching for a familiar glimmer, the telltale colours of a sun-like star, or the faint dimming of starlight that hints at an orbiting planet. In recent decades, astronomers have found thousands of planets circling other suns. Some are inhospitable gas giants or scorched rocky orbs, but a precious few reside in the comfortable band around their star, where life, as we know it, might thrive. One of these could be a new Earth, a second home for humanity beneath an alien sky. Imagine the moment of discovery. A distant star's light yields the chemical signature of air and water, perhaps even the faint imprint of organic life. A world that has everything our home does: blue seas, clouds drifting above green continents, only waiting for visitors from across the cosmos. Finding such a world is like spotting an island on the far side of a vast ocean, a promised land in the distance. With a destination in mind, our journey gains purpose and hope. Yet between us and that new world lies the enormous emptiness of space. The gulf between stars is not truly empty. It is filled with a thin haze of ancient stardust, stray atoms, and the ghostly whisper of old light. But to human senses, it is a perfect vacuum, cold and forbidding. There are no waypoints in that darkness, no ports of call to refuel or repair. A starship setting course beyond our sun must carry with it everything it needs, for it will find nothing along the way but the subtle glow of nebula and the faint tug of distant gravity. Navigation itself becomes a challenge when the usual landmarks fade. Back in our solar system, navigators could use the sun, planets, and even Earth's magnetism to find their way. In interstellar space, the only landmarks are the stars themselves, and they hardly shift position at all in the short term. Our explorers may fix their gaze on one star, using its light as a guide. They might also use the gentle beacon of pulsars, spinning neutron stars whose radio pulses are as steady as a metronome, as cosmic lighthouses to check their position in the void. And even in this emptiness lurk tiny dangers. A stray mote of dust, no larger than a grain of sand, becomes a high-speed missile to a ship racing through the void. Without an atmosphere or magnetic field to shield it, the starship must rely on its own armor and deflector fields to withstand the onslaught of invisible cosmic debris. Every course must be plotted to avoid dense regions of gas and dust, every hull plate engineered to absorb micrometeoroid impacts. For beyond the heliosphere, the sun's protective bubble, the crew are exposed to the galaxy itself. Cosmic rays, the high-energy particles from distant supernovas, streak through interstellar space unhindered. The starship's hull will serve as a second sky, shielding its passengers as best it can from radiation that would, over years, silently damage their cells. To go beyond our sun means to venture into a realm where space itself can be hostile in ways our ancestors never faced on the oceans of Earth. As the journey begins, the last rays of our sun grow ever fainter. Behind the ship, the sun shrinks to a bright star, then a pinpoint, until it is lost in the glittering tapestry of the Milky Way. All that remains of home is the knowledge carried in the minds and hearts of the crew, and the signals trailing off into the distance. A farewell in the form of a faint radio whisper that grows weaker with each passing day. Ahead lies darkness and anticipation. Each passing year, the target star will shine a little brighter, a tiny pinprick of hope growing in the viewport. The journey may be long, years, decades, perhaps longer. But every great voyage is made of many small steps. In the silence of interstellar space, time itself becomes a companion, measured out in heartbeats and the slow ticking of onboard clocks. Charting a course to the stars is not just a matter of physics and astronomy, it is also a leap of faith and imagination. We must have faith in our technology to sustain life far from any help, faith in our calculations that we will arrive where we intend to, and faith in ourselves to endure the isolation of the great abyss. We imagine the starship and its crew as a tiny spark crossing a huge, dark room. The spark is fragile, but it carries the fire of human spirit. Each person aboard carries memories of Earth, the smell of rain on soil, the sound of leaves in the wind, the face of a loved one left behind. Those memories will travel with them, little pieces of home glowing in their hearts as they venture into the unknown. There is mystery in this voyage that no amount of planning can erase. Beyond our sun, we truly do not know what awaits. Will the star we aim for be exactly as we expect when we arrive? Or will it hold surprises, unseen moons, rings of dust, or phenomena our instruments failed to detect from afar? The crew can only wonder as they sail further from certainty. They might picture the planet awaiting them, trying to imagine its skies and landscapes from the scant data sent across light years. In their dreams, perhaps they already walk its alien shores, under strange constellations, hearing the whisper of a foreign wind. For now, those visions are just dreams, to keep hope alive through the long night of travel. To turn them into reality, we must solve challenges unlike any faced before. It all begins with the ship and its propulsion, the engines that will carry us across the stars. The physics of our universe sets a strict speed limit. Nothing with mass can travel faster than light. To traverse light years in a human lifetime, or something close to it, we will need to reach extraordinary speeds, a significant fraction of light's velocity. Traditional rockets that took astronauts to the moon or robots to Mars won't suffice. Their fuel would be exhausted long before reaching even a tiny fraction of the distance. We need something far more powerful and efficient, something worthy of the interstellar frontier. Thus, as humanity plots the path to another sun, our attention turns to the engines of tomorrow, revolutionary propulsion systems that might one day blaze a trail between the stars. The dream of interstellar travel has always been twinned with the dream of new engines to propel our ships. Fire alone, chemical rockets, got us off Earth and to our neighbouring worlds. But fire will not carry us to Alpha Centauri or beyond. We will need to harness fundamental forces of nature in ways we have never done before. As our starship drifts farther from the light of home, let us delve into the ideas and innovations that will drive it onward. Out in the interstellar dark, we ignite a new kind of flame, one that burns not with mere chemical fuel, but with the very stuff of stars and the secrets of the atom. The journey to the stars begins with a spark of inspiration, and that spark will light the engines of tomorrow. How could our tiny spark of a starship ever hope to cross those light years? The answer lies in engines far mightier than any we have ever built. Engines that harness the fundamental powers of the universe. In the quest to reach another sun, three extraordinary ideas have emerged: driving our vessel with the fire of fusion, with the annihilating energy of antimatter, or with the gentle push of light itself. The first of these promises draws directly from the stars: nuclear fusion. Fusion is the process that makes our sun and all stars shine, the fusing of light atoms into heavier ones, releasing tremendous energy. For decades, humanity has sought to tame fusion for clean energy on Earth. To use it for propulsion is an equally daunting challenge, but one brimming with possibility. Imagine a starship engine that contains a small star's fury, using it to propel the ship onward. Deep in the heart of such an engine, tiny pellets of hydrogen fuel, perhaps special forms like deuterium and helium-3, are fed into a reaction chamber. There, a powerful pulse from lasers or electromagnetic fields crushes each pellet in an instant, forcing the atoms inside to fuse, just as they would in the core of a star. Each fusion pulse is like a miniature sun igniting for a fraction of a second, releasing a burst of energy and high-speed particles. Magnets then channel this hot plasma out the back of the engine, creating thrust. To the crew on the ship, it might feel like a steady push, but in reality, it is a rapid-fire sequence of tiny starbursts, hundreds per minute, propelling them forward with the power of nuclear fire. Such fusion engines could, in theory, accelerate a starship to a significant fraction of the speed of light, where a chemical rocket would exhaust its fuel long before attaining even 1,000th of light speed. A fusion drive might reach 10% of light speed or more. At 10% of light speed, the journey to the nearest star could be as short as a few decades, within one generation's lifetime. This is still an immense voyage, but it is a far cry from the tens of thousands of years a conventional rocket would require. In the minds of dreamers and engineers, fusion propulsion turns the stars from unreachable beacons into destinations perhaps attainable within a century. Yet the challenges are enormous. To create and control a fusion reaction is no simple feat. Even our most advanced laboratories on Earth have only just begun to achieve fleeting sparks of fusion power after decades of effort. A starship would need not one spark, but a continuous stream of controlled fusion events, safely contained and directed. The reactor must handle temperatures and pressures akin to the core of a star, again and again, without fail. The walls of the engine chamber would glow with intense heat and radiation. Powerful magnetic fields, invisible cages of force, would be needed to bottle up the fusion fire so it doesn't damage the ship or harm the crew. And then there is the fuel. A journey to another star might demand thousands of tons of hydrogen fuel, perhaps collected from gas giant planets or manufactured in orbit before departure. Futuristic fuel depots around Jupiter or Saturn could stockpile helium-3 from their atmospheres, providing the lifeblood for fusion engines. Despite these challenges, the fusion starship remains one of the most tangible hopes for interstellar travel. In the late 20th century, bold conceptual designs were drawn up for fusion-powered probes, enormous vehicles that could, theoretically, reach nearby stars in less than a human lifetime. Those early designs were never built, but they planted a seed. Today, as we envision travelling beyond our sun's domain, we nurture that seed with advanced research. Perhaps our first journey to the stars will indeed be aboard a ship powered by a captive sun, riding a beam of its own fusion fire across the dark. If harnessing a star's power is one path, the second path taps into an even more potent source of energy, something that makes fusion look modest by comparison. That is antimatter, the strange mirror twin of ordinary matter. In the everyday world, when matter meets matter, nothing extraordinary happens. They might combine chemically or bounce off each other. But when matter meets antimatter, they annihilate one another in a flash of pure energy. It is as if all the locked-up energy inside the particles is suddenly released at once. According to Einstein's famous equation, E mc2, even a tiny amount of mass, when converted fully to energy, yields a tremendous burst. For example, a few grams of antimatter reacting with matter could produce as much energy as millions of kilograms of chemical fuel. Such is the promise of an antimatter engine. With only teaspoons of fuel, a starship might carry enough energy to cross light years. Picture an antimatter rocket. At its core is a trap holding antihydrogen, atoms of antiprotons and positrons, confined by powerful magnetic fields so they never touch the walls. To produce thrust, just a few particles of this ghostly fuel are allowed to meet normal particles. When they do, they vanish in a furious release of high-energy radiation and charged particles. These fast-moving particles can be directed by magnetic nozzles out the back of the engine, generating thrust. There's no need for oxygen or any oxidizer, as in a traditional rocket. The annihilation provides all the energy needed. The result is an engine with an energy-to-weight ratio far beyond any conventional design. With such efficiency, an antimatter-driven starship could potentially attain even higher speeds than a fusion-driven one, perhaps 20 or 30% of light speed, according to optimistic studies. At those speeds, the nearest stars come within reach in a couple of decades, and even somewhat farther stars could be reached in a human lifetime. It's no wonder that antimatter propulsion is often cited as the ultimate solution for interstellar travel. But as with all things that sound too good to be true, there are formidable hurdles to overcome. The first is obtaining the antimatter in the first place. Antimatter is exceedingly rare in our universe. Almost all of it was destroyed when the cosmos was young, and only trace amounts appear naturally, for instance, in cosmic ray interactions, or trapped in the Van Allen belts of planets. We have learned to create antimatter in laboratories by smashing particles together at enormous energies. But the quantities are minuscule, and the process consumes far more energy than the antimatter itself provides. To gather milligrams or more for a starship, humanity would need a major breakthrough. Perhaps dedicated antimatter factories, powered by vast solar farms or fusion plants, slowly accumulating anti-atoms over years. It would be like filling a lake one drop at a time. Then comes storage. How do you bottle a substance that annihilates ordinary material on contact? The only way is to never let it touch anything. Keep it suspended in electric and magnetic fields, in high vacuum, at ultra-cold temperatures, so it remains stable and isolated. This demands extremely precise, fail-safe technology. One glitch, one stray atom of air, and the stored antimatter could erupt in an uncontrolled burst of energy. The starship's fuel tanks for antimatter might look like shining magnetic cages, holding shimmering specks of anti-fuel that hover in mid-air, isolated from the walls. Every precaution would be taken to ensure those specks remain exactly where they belong, day after day, year after year of the journey. Finally, controlling the release of energy for thrust is another challenge. You would want a steady, manageable output, not a single catastrophic flash. One concept is to feed antimatter in tiny doses into a reaction chamber where it meets a stream of normal propellant, perhaps hydrogen, so that each annihilation event heats and expels a larger mass of reaction mass, producing thrust much like a conventional rocket, but with an immensely potent heat source. Another idea, as mentioned, is to use antimatter as a trigger for fusion reactions, blending the two methods. In that scenario, the antimatter ignites small fusion pellets, and the combined energy of fusion and annihilation is directed for thrust. This could temper the raw power of antimatter with a bit more control. If we can ever surmount these obstacles, an antimatter starship could be our fast ticket to the stars. It represents a pinnacle of energy release, tapping into the fundamental energy of matter itself. The gleam of an antimatter drive in the night sky, if such a thing were visible, would outshine any rocket plume we've known. It would be a beacon of humanity's mastery over nature's most violent energies, used for the peaceful purpose of exploration. Yet, even as we imagine these spectacular engines, fusion and antimatter, there remains a third idea that is in many ways simpler, yet profoundly different. Instead of packing enormous energy on board our ship, why not harness the energy already abundant in nature? Why not ride on beams of light to the stars? This is the idea behind light sails. A light sail, as the name suggests, works a bit like the sail of an old sailing ship, but instead of catching the wind, it catches light. Photons, the particles of light, have no rest mass, but they carry momentum. When they bounce off a reflective surface, they impart a tiny push. On Earth, this force is too small to notice, but in the vacuum of space, with a large enough sail, even a gentle push can, over time, accelerate a craft to tremendous speeds. Picture a spacecraft that is essentially a giant, shining sail, perhaps kilometers in diameter, but made of material thinner than paper. It unfurls in space, becoming a vast mirror facing the sun. Sunlight strikes it and pushes it outward. Slowly, the spacecraft begins to drift faster, like a boat catching a steady breeze on a calm sea. To truly achieve interstellar speeds, however, we would likely assist sunlight with lasers. We can imagine a future Earth, or perhaps a lunar base, hosting an array of powerful lasers, all trained on the departing sail. The combined beams flood the reflective surface, giving it a far stronger push than sunlight alone. Under this barrage of light, the starship's acceleration grows and it starts to pick up speed. There is no fuel being burned on the ship. The energy comes from behind, from those distant lasers, or the sun itself. To any travelers on board, the journey begins almost silently. If they looked back, they might see a distant, intense sparkle where the lasers remain locked on the sail. Over days or weeks, the ship gathers momentum. In the frictionless void, that momentum accumulates until the ship is moving at a significant fraction of the speed of light. We have already taken the first small steps toward this vision. In Earth orbit, Small solar sails have unfurled and caught the sun's rays, proving that photon propulsion is real. One early 21st century project sent a tiny sailcraft beyond Earth orbit, raising its speed using only sunlight. These experiments are modest, but they herald a possible future. For a true interstellar sail, the scale would be vastly larger, a sail spanning kilometers, driven by lasers, powered by perhaps a large fraction of a planet's energy output. It's a daunting engineering challenge, but notably, it doesn't violate any laws of physics, just pushing current physics to new extremes of scale and precision. One crucial factor for a laser-driven sail is aiming. The laser array must remain precisely focused on the sail across millions of kilometers. If the beam strays or weakens too soon, the acceleration could end prematurely. As the ship races away, the beam will spread out, losing intensity. So the initial phase of the journey is key to reaching high velocity. After a certain point, perhaps after days or weeks of acceleration, the ship might be too far to effectively illuminate. At that stage, it would detach from its light source and simply coast through interstellar space at the velocity it achieved. When approaching the destination star years later, slowing down is another challenge. A light sail could potentially use a similar principle to brake. By flipping around to face the direction of travel, it can use the pressure of the destination star's light to decelerate. Alternatively, the ship might carry some conventional propellant for braking, or even have a smaller sail that can catch a laser beam sent ahead to slow it. Another idea is using a magnetic sail, a kind of magnetic field deployed by the ship to interact with the tenuous gas of the interstellar medium, creating drag. All these methods are speculative, and an interstellar sail mission would need careful planning to ensure that the craft can not only speed up, but also come to a stop at journey's end. Light sails captivate our imagination, not only for their technical promise, but for their almost poetic resonance. They recall the great age of sail on Earth, when explorers ventured across unknown oceans with canvas and wind, not knowing what lay beyond the horizon. In the cosmic version, the wind is photons, the sail is a shimmering mirror, and the ocean is the black vacuum of space. It's a quiet, seemingly gentle way to traverse the stars. One can imagine standing on the deck of such a starship, if it had something like a deck, gazing up at a taut, silver sail that fills the sky, shining with reflected starlight. There's no rumble of engines, only the silent pressure of light carrying you onward. Such a journey could be long and filled with solitude, but it would be serene and steady, propelled by the fundamental light of the universe. Between fusion rockets, antimatter drives, and light sails, humanity's potential toolkit for reaching the stars begins to take shape. None of these technologies is easy. All of them will require breakthroughs in science and engineering before they can become reality. But they offer a roadmap, however challenging. We can foresee a future where a spacecraft might depart Earth's vicinity under laser power, coast through the interstellar dark on inertia, then perhaps fire up a fusion engine for final adjustments as it approaches a new star. Or perhaps one day we'll develop a way to harness antimatter safely and use it to dash between stars at unprecedented speeds. There could even be hybrid systems, maybe a sail to start, then a fusion boost, or antimatter-initiated fusion pulses. The possibilities give engineers and dreamers much to ponder. What matters is that interstellar travel is no longer purely the stuff of fiction or fantasy. The gap between stars, while unimaginably vast, is not unbridgeable. We are slowly assembling the pieces needed to cross it. Each year, progress is made. A longer-lasting fusion reaction in a lab, a new record for antimatter storage time, a larger and more reflective sail material developed. These are incremental steps, but each one brings the dream a little closer. And one day, when those engines do ignite, or when that sail catches the light, humanity will embark on its greatest journey. Still, as formidable as these propulsion systems are, they obey the cosmic speed limit. They will not get us to the stars in an instant, nor allow us to flit casually from one end of the galaxy to the other. For that kind of freedom, we would need to dream even bigger, to rewrite the rules of space and time themselves. It is a leap that ventures firmly into the realm of theory and speculation, but for completeness, and for the sake of dreaming without bounds, we must contemplate it. The concepts of warp drives and wormholes. These ideas promise, at least in principle, to cut travel times from years to hours, or to connect distant corners of the cosmos through shortcut tunnels. Before the first starship ever embarks, we should explore these far edges of possibility, for within them lies the hope of turning interstellar voyage from a long odyssey into a brief sojourn. Let us venture now into the speculative realm of warping space-time and see what marvels or perils it might hold. Imagine if distance were no barrier, if we could simply step from one star to another, almost as easily as walking through a doorway. This is the seductive promise of warping space-time. The idea that perhaps we can cheat the rules laid down by light speed by bending the very fabric of reality. It sounds like magic, but it arises from real physics, from the fact that space and time are flexible, bendable, under the right conditions. If we could master this art, our starship's journey might take not decades or centuries, but perhaps mere hours or minutes. One way to envision this is through the concept of a wormhole, often imagined as a tunnel through space-time, connecting two distant points via a shortcut. Picture the vast distance between Earth and a far-off planet as a long sheet of paper. Normally, you would have to travel across the sheet from one end to the other. But what if you could fold the paper, bringing those two distant points together? Punch a hole through the folded paper, and suddenly, the start and end of your journey touch. Unfold the paper, and now you have a tunnel, a wormhole, bridging what used to be an enormous gulf. In theory, if such a wormhole could be created and held open, a traveller might enter on Earth's side and emerge at the distant planet almost instantly, effectively sidestepping the intervening light years. Wormholes are not merely fantasy. They appear in the equations of Einstein's general theory of relativity. Einstein himself, along with physicist Nathan Rosen, discovered what we now call an Einstein-Rosen bridge, essentially a wormhole, as a mathematical solution describing a connection between two black holes. However, those early visions of wormholes had a problem. They were not traversable. They pinched closed so quickly, faster than the speed of light, that nothing could pass through from one side to the other. To be useful for travel, a wormhole would have to be held open against this natural tendency to collapse. This is where the idea of exotic matter comes in, a hypothetical substance with negative energy or negative mass. In our everyday experience, Matter has positive mass and energy, which produce gravity that pulls things together. Negative energy, in contrast, would gravitationally push things apart. It's like anti-gravity. If one could line the throat of a wormhole with something that has negative energy, it might act as a kind of strut or pressure pushing outward to keep the tunnel open. This sounds incredibly fanciful, because it is. No known material has these properties, although quantum physics offers some phenomena, like the Casimir effect in a vacuum, where energy can be negative in a tiny region. But even if negative energy can exist in principle, generating enough of it to prop open a wormhole of usable size is far beyond our current reach. Still, as a thought experiment, suppose someday we discover either naturally occurring wormholes or a means to create them artificially. What would travelling through one be like? The truth is, we're not entirely sure. If the wormhole is stable and large enough, in theory, you might see a strange distortion of light at its mouth. Perhaps the far end stars and space distorted into a swirling mosaic, like looking through a funhouse mirror or a rippling pond surface. Entering it might feel uneventful physically. You might not even realize the moment you passed the midpoint, but your instruments would show something astonishing. A sudden shift in the stars, an abrupt change in the cosmic scenery as you emerge somewhere far, far from where you began. It could be a disorienting moment. One instant you're near Earth, the next you're under the sky of an alien star system, with constellations utterly unfamiliar. Imagine stepping out and seeing two suns in the sky, or a ringed giant planet looming on the horizon, all because you took a shortcut through space-time. The sheer wonder and potential danger of such a journey are the stuff of dreams and science fiction alike. We would have to be extraordinarily careful, misjudge a wormhole, and you might end up who knows where, or trapped if it closes behind you. Because of these uncertainties, many scientists are cautious. Some suspect that even if traversable wormholes exist, nature might protect causality, the order of cause and effect, by making them untraversable if anyone tries to use them for backwards time travel or other paradoxical situations. Yes, wormholes raise the prospect of time tricks. Go through one, come back through another, and you might emerge before you left, which opens a Pandora's box of paradoxes. It could be that the universe simply doesn't allow those scenarios to fully play out in reality. Parallel to wormholes, another concept for faster-than-light travel involves not tunnels, but riding a wave of bent space. The idea of a warp drive. Instead of making a hole through space-time, a warp drive would distort space-time around a vessel. The most famous theoretical model for this is the Alcubierre warp drive, named after Miguel Alcubierre, the physicist who proposed it in 1994. In his idea, a bubble of space-time is generated around a ship. By expanding space-time behind the bubble and contracting it in front, the bubble itself can move faster than light relative to the surrounding space, even while the ship inside never locally breaks the speed of light. The ship isn't moving through space faster than light. Instead, space itself carries the ship along like a conveyor belt, or a surfer riding a wave. Think of it like this. Normally, to travel from star A to star B, you'd have to trek across the intervening space. With a warp drive, you would gather the space behind you and stretch it out, and compress the space in front of you. To an outside observer, you'd vanish from near star A and appear near star B faster than any light ray could have made the journey. But inside the bubble, the passengers feel like they're stationary, or maybe gently moving. They might not sense anything unusual at all. It's as if the universe itself is doing the traveling for them. This concept also stems from Einstein's theory. It's known that space can expand faster than light. Indeed, in the cosmology of the Big Bang, space expanded immensely in fractions of a second. So the trick is not to go through space faster than light, but to make space itself move. However, here too, an exotic ingredient is required: negative energy. The warp bubble's edges, as Alcubierre described, would need to be filled with a form of energy that has a repulsive gravity effect to effectively push space apart and squeeze it elsewhere. The quantities initially calculated were astronomical, far more energy than anything humans could dream of harnessing, maybe more than exists in the observable universe. Later refinements to the theory suggested ways to dramatically reduce the energy requirement, but it's still huge and still requires that baffling negative energy stuff. Even if a warp drive could be constructed, it raises its own puzzles and risks. For one, creating that bubble and moving it might produce intense radiation or shocking effects when you arrive and turn off the drive. Imagine a wave of high-energy particles released as the bubble decays, potentially harmful to anything nearby. There are even musings about what happens if something, like interstellar dust, gets caught in the warp field. Could it accumulate deadly cosmic rays that then blast forward into the destination? These remain theoretical concerns, because no one's built a warp drive to find out. Despite these issues, the allure of warping space-time remains strong. Scientists and dreamers occasionally publish papers exploring these concepts, trying to edge a little closer to feasibility. Perhaps one day, a breakthrough in physics, something to do with quantum gravity or higher dimensions, will show a path to create a tiny warp bubble or a microscopic wormhole. It might start small, just enough to send a particle or a bit of information through. From there, who knows how rapidly things could advance? If the door even cracks open to these possibilities, the urge to push it wide for star travel would be irresistible. For now, though, warp drives and wormholes live in the realm of equations and imagination. They remind us that the universe might have loopholes we don't yet fully grasp. They also remind us that nature's laws are not easily circumvented. If they were, we might already see evidence of other civilizations zipping around the galaxy via shortcuts, assuming such civilizations exist. The silence out there could be a hint that the cosmic speed limit is as firm as it seems, and that any shortcut requires Herculean effort or new physics to exploit. So as our interstellar travelers prepare to leave, it's likely they won't be taking a magic portal or a warp highway. Their journey will probably be long and demanding, relying on the engines of tomorrow, rather than the miracles of far future physics. And this means that, unless we find a way to put people into stasis or suspended animation, those who set out may live the rest of their lives in transit, and their children or grandchildren will be the ones to finally arrive. This is the idea of a generation ship or interstellar arc, a self-contained world on a voyage across the stars, where generations are born, live, and die on the way to a new home. Such a life is a dramatic departure from anything humanity has experienced before. It requires creating a miniature, sustainable ecosystem and society that can endure isolation for decades or centuries. As our story continues, we board one of these world ships and explore what life might be like for those generations in transit, carrying the hope of humanity to a distant shore among the stars. Now we step inside an interstellar ark, a generation ship. This enormous vessel is more than a ship. It is a moving world, carrying the seeds of a future civilization. From the outside, it might resemble a giant spindle or cylinder, slowly spinning in the starlight. That rotation is deliberate. Inside, it simulates gravity, pressing people's feet to the floor so they can live and work in Earth-like conditions. As we enter through an airlock, leaving the emptiness of space behind, we find ourselves in a corridor that could be mistaken for one in a modern building back on Earth. The air is warm and carries a faint smell of vegetation. Lights on the ceiling mimic the golden glow of sunlight. We hear faint echoes of life, distant footsteps, perhaps laughter, the everyday sounds of a community. This ship is a self-contained biosphere. Every drop of water, every breath of air is recycled in a never-ending loop, because nothing can be wasted on a journey that spans generations. In hydroponic gardens, plants grow under bright lamps, their green leaves turning carbon dioxide from the passenger's breath back into oxygen. There might be whole gardens and small forests aboard, providing not just food and air, but a psychological balm, patches of nature to calm the mind. Bees might buzz among fruit trees in a greenhouse, unaware that outside the hull is a vacuum and an endless night. Fish could swim in tanks as part of an aquaponic system, filtering water and helping to grow algae or vegetables. The hum of machinery underscores it all. Pumps circulating water, fans moving air, the gentle thrum of the ship's engine far in the stern, providing power and occasional course corrections. As we walk further in, we come to a large open space, perhaps a central park of the ship. Here, under an arched dome lined with panels simulating a blue sky, a small community gathers. Children are playing a game on the grass. Yes, grass grows here, rooted in specially made soil that is part of the life support ecosystem. A couple of adults sit on a bench, chatting quietly, maybe discussing the day's work maintaining the solar panels or the results of a recent systems check. Elderly folks stroll slowly along a path, pausing to enjoy the vibrant flowers climbing a trellis. It is a peaceful scene, reminiscent of any small town square on Earth. Yet we are hurtling through interstellar space at an unimaginable speed. Outside that simulated patch of sky is a view of the stars that scarcely changes to the naked eye, tiny points of light that shift only over years. Life aboard a generation ship finds a rhythm. There is day and night, as lights brighten and dim to create a 24-hour cycle, keeping people's circadian clocks in tune. People wake in the morning to the soft glow of sunrise in their cabins. They have breakfast, perhaps eating fresh produce grown right on the ship, like tomatoes or berries, along with staples produced from stored supplies or cultivated algae processed into nourishing meals. Everyone likely has a role or job, because running a world ship requires many hands and skills. Some are engineers, tending to the reactors, engines, and structural integrity of the vessel. Others are farmers and biologists, caring for the crops, animals, and life support systems that keep the environment balanced. Teachers are essential, for the knowledge of Earth and the mission must be passed down faithfully to those who were never born on Earth. Medics and doctors ensure the health of the population, which might number in the hundreds or even a few thousand. Education on the ship is a unique thing. Picture a classroom where children gather not only to learn the usual subjects of math, science, and literature, but also to learn about Earth, a place none of them have ever seen. A teacher shows images and videos of oceans and mountains, of rain falling and birds flying. The children listen to recordings of rainstorms and animal calls to connect them to their heritage. They are taught that their great-grandparents came from that blue world, and that their own grandchildren might one day walk on another planet's soil. They learn about the mission, why they are here, where they are going, and what they must do when they arrive. Perhaps there is a motto or creed aboard, something like, "We carry the dreams of Earth to the stars." It gives them a sense of purpose and destiny. Growing up on a generation ship, a child's entire universe is the ship. Corridors and compartments, the central park, the observatory deck with its windows to the cosmos. These define their world. They might press their nose to a porthole at the edge of the habitat section and peer into the blackness of space, seeing the faint glow of a nebula or the bright pinprick of a nearby star. It might be hard for them to grasp just how far away those stars are, and that their ship is actually moving incredibly fast. For them, the ship feels still and stable, a home that always was and always will be, at least until they reach the destination. Society on board will evolve over time. The first generation might remember Earth vividly and feel its loss keenly. They left behind open skies, wind, and the vastness of nature. They carry those memories, and perhaps a longing or homesickness. The second generation, born in transit, hears stories of Earth, but know no other life than the halls of the ship. To them, the ship is comfortable, but perhaps sometimes stifling. They cannot run endlessly in one direction without coming back to where they started. Adolescents might feel the confines and yearn for more freedom or novelty. Maintaining morale and mental health is a continuous task. The ship's counselors or community leaders might organize virtual reality sessions where people can experience more varied environments, or celebrations and festivals to mark the passage of time and keep spirits high. There could be holidays commemorating the launch or significant milestones achieved, giving people regular occasions to look forward to and break any monotony. Over many decades, the culture aboard the ship might diverge from Earth's in subtle ways. Language could develop new slang that reflects life in space. Perhaps new traditions form, like a day of remembrance, where the tale of Earth and the decision to voyage is retold so it is never forgotten. Or a day of hope, where the vision of the new world is shared in stories and songs. Music and art created on the ship might reflect the unique environment. Imagine lullabies that sing of shining stars outside the window, or murals painted along the curved walls, depicting both Earth and the imagined landscapes of the future colony. There will be challenges beyond the technical. Interpersonal conflicts in such a confined community must be carefully managed. Everyone knows that, for the mission to succeed, cooperation is vital. Serious crimes or discord could threaten the fragile ecosystem of society on board. Therefore, there may be strict social rules or a strong shared ethos of unity and conflict resolution. When disputes arise, elders or elected councils might mediate. Privacy is precious in a place where space is at a premium. Quarters are small, and communal living is the norm. Designs of generation ships often include thoughtful architecture, little nooks for quiet retreat, soundproof sections where one can be alone with their thoughts, and multi-use spaces that can transform from dining hall to recreation room to meeting chamber as needed. Time takes on different meaning in transit. On Earth, a year is marked by seasons, by Earth's journey around the sun. On the ship, perhaps they keep an Earth calendar to mark birthdays and ages in Earth years for consistency, but they might also mark ship years or the time since departure. A child might proudly say, "I am 10 years old, born 7 years after launch." Meanwhile, mission control on Earth might still exchange messages with the ship for a while, though as distance grows, the communication lag becomes hours, then days, then years. Eventually, those aboard might be essentially on their own, with any message from Earth being a voice from the past. By the middle of the voyage, no one alive on the ship remembers Earth firsthand, and no one alive on Earth truly knows the people on the ship. Yet the chain of continuity persists through the recorded knowledge and culture passed down. Amidst routine and duty, there are also moments of high drama and wonder. Think of the excitement when, perhaps once a generation, the ship's astronomers announce that their telescopes have picked up a clear view of the target star's planets, maybe even glimpses of the new world, still just a tiny speck. The whole ship might gather in the observatory dome to witness this, hearts swelling with anticipation, or consider the emotion of a funeral on a generation ship, saying goodbye to an elder who was one of the last born on Earth, their stories now entrusted to younger minds. The community might have special rituals for such events, celebrating the person's life and their role in the grand voyage of humanity. The physical health of a closed community is also carefully watched. Medical officers ensure that the population maintains genetic diversity. There might be a sperm or egg bank brought from Earth to introduce genetic variety, if needed, over generations. They also guard against disease. A pandemic on a generation ship would be dire, so stringent measures exist to handle any outbreaks quickly. Vaccines and regular health checkups are routine. Perhaps even surgeries and advanced medical care are aided by AI or robotic surgeons, given the limited medical staff. Despite the constraints, there can be a profound sense of meaning for those on board. They are the pilgrims of the galaxy, carrying humanity's aspirations. Every dawn simulation and every night, they know they are part of something historic. They are the bridge generation, connecting the cradle of Earth to the new frontier. Their entire society is built around a singular goal: to survive the journey and give their descendants the chance to begin anew on an alien world. This shared purpose can be a powerful glue, binding people together in ways that might even be stronger than the communal ties back on Earth, where society often fragments into many different directions. And so the years pass quietly aboard the ship. Children grow up, assume the roles of their parents, maintain the ship as it hurtles onward. The stars outside slowly shift positions. The destination star grows ever so gradually brighter. Perhaps one night in the observation dome, a young woman sees a new pinprick of light that wasn't there before. It's not a star, but the faint glow of the target planet seen through a telescope. A tiny promise shining in the distance. She points it out to her friend, and soon a small crowd gathers, whispering with excitement and wonder. Word spreads, and for days, that is all the talk. People visit the telescope to glimpse their future home. It ceases to be just an abstract concept and becomes real in their eyes. Life aboard an interstellar ark is a long exercise in patience, hope, and diligence. The journey tests not only the engineering of the vessel, but the endurance of human spirit and community. Many, many years after departure, the ship will finally approach its destination. The people on board, by now the great-great-grandchildren of those who left Earth, will be both the crew of the ship and the first settlers of the new world. What will they find when they land? How will they adjust to a planet under an alien sun, with open skies and weather and perhaps unfamiliar life? These questions loom as the planet draws near, both thrilling and daunting. That beacon ahead was not found by chance. Long before any starship set sail, humanity first had to find the shores on which to land. The search for Earth 2.0, a planet outside our solar system that could be a true home for life, was one of the great scientific quests of the 21st and 22nd centuries. Night after night, an armada of telescopes, both on Earth's mountaintops and in space, scanned the sky, studying the faint twinkling of distant stars for any telltale signs of orbiting planets. Every tiny dip in a star's brightness, every slight wobble in its spectrum, could mean a planet passing in front or tugging at its sun. A clue that a world was there, hidden in the glare of its star. The first discoveries were mostly giant planets, enormous hot Jupiters that were easier to detect. But as technology improved, attention turned to smaller, rockier worlds, especially those at just the right distance from their stars, where temperatures might allow liquid water on their surfaces, the so-called habitable zone. Astronomers found many planets in that zone, but not all are truly Earth-like. Some are much larger, super-Earths, that might be more like mini-Neptunes with thick atmospheres. Others orbit stars that flare harshly, or are tidally locked with eternal day on one side and night on the other. The search for a true Earth twin, a temperate rocky planet circling a stable, sun-like star, was challenging. Imagine the excitement on the day that one particular star's light revealed a promising signal. In the data, a periodic dip emerged. Every so many days, the star dimmed just a little, as something small and round crossed in front of it. The pattern indicated a planet, one only slightly larger than Earth. Calculations suggested it orbited in the middle of the star's habitable zone. The star itself was a steady, middle-aged star, not unlike our Sun, though a bit smaller and redder, lying perhaps a dozen light-years away. Quickly, telescopes around the world pivoted to study this star in more detail. They measured the slight gravitational tug the planet exerted on the star, which told them the planet's mass. Good news. It was likely a rocky world, not a gas giant. Its orbit was neither too close nor too far. Perhaps a year, there was a bit longer than an Earth year. It might have a mild climate, maybe somewhat cooler or warmer, depending on its atmosphere. Next came the analysis of starlight, filtering through that planet's air, a tricky feat. Using a combination of a large space telescope and a clever instrument called a spectroscope, scientists spread out the star's light during a planetary transit into a rainbow and looked for faint fingerprints of chemicals. What they saw made them gasp. Hints of water vapor, and even more tantalizing, a pattern that suggested oxygen. Oxygen is hard to accumulate naturally. On Earth, it's continually produced by life. Plants, algae, photosynthetic bacteria. Its presence in a planet's atmosphere can be a strong, though not conclusive, sign of life. Alongside oxygen, there were hints of other gases, like a bit of carbon dioxide, which is fine, may be needed for warmth, and perhaps a trace of methane. The mix didn't guarantee an ecosystem, but it was very suggestive. It looked like this planet might not only be habitable, but inhabited, even if just by simple life, like plants or algae. The world's media dubbed the planet Earth 2.0 in headlines, though scientists gave it a catalogue name and later a more poetic name inspired by mythology. Many started simply calling it New Earth informally, because if any place could be a new home for humanity, this was it. Imagination soared. Artists painted pictures of what New Earth might look like. Perhaps blue oceans covering part of its surface, with green continents under skies of soft clouds. If its star was a bit redder than the sun, maybe sunsets there would blaze in shades of deep crimson and purple. Perhaps the vegetation, if it existed, had evolved hues to absorb the star's light. Maybe it was green like our plants, or maybe darker, almost black foliage to soak up the dimmer red sunlight. While we could dream, science marched on methodically. Plans were made to send robotic probes, if possible, to scout further. With advanced propulsion, maybe using solar sails or tiny laser-driven chips, a few miniature probes were dispatched toward New Earth years ahead of any crewed mission. These were the precursors. They would arrive and beam back close-up data. It would take years for them to reach and years for their signals to return. But one day, humanity received something miraculous. The first direct images of an exoplanet's surface. Though the probes were small and not capable of landing, they zoomed past the planet and snapped pictures. Grainy, and from afar, the images still showed continents and seas. One photo captured the gleam of starlight off what had to be an ocean. Another showed the curve of the planet's limb with white cloud swirls, indicating weather, perhaps even a stable climate system. It was confirmed. This was a water-rich world, with an atmosphere and likely a hydrologic cycle of clouds and rain, just like Earth. The probe's instruments also took more detailed readings of the atmosphere. They detected a subtle imbalance in the gases that strongly hinted at life processes. There was more oxygen than one would expect if only volcanoes and geology were at play, and methane that shouldn't coexist with so much oxygen, unless it was being replenished by something, perhaps microbial life. This wasn't proof of little green men, of course, but it was enough to electrify everyone. New Earth seemed alive, at least on a basic level. It was as if we had detected a garden in a previously thought barren desert. With this discovery, the question changed from, is there another Earth, to, when do we go, and how do we protect it when we get there? There were ethical discussions. If the planet has its own life, even simple, should humans go and potentially disrupt it? Might we contaminate a pristine biosphere, or, conversely, might whatever microbes live there harm us? Plans evolved to ensure sterility protocols for the starship, to guard against cross-contamination, and a promise was made to study and respect any native life forms. Finding Earth 2.0 was a turning point. It gave humanity a goal that was not just about survival, but about exploration and even companionship in the cosmos. We knew at last we weren't the only oasis of life. There was at least one more, waiting. And if there was one, surely there would be others in the vast galaxy. The discovery spurred investment and enthusiasm in interstellar travel like never before. Those advanced engines we discussed earlier, fusion drives, lasers for light sails, etc., suddenly moved from theoretical projects to urgent endeavours. International and interdisciplinary teams formed, pooling resources on a scale not seen since perhaps the Apollo era or the building of the great space stations. This time, it was not just one nation or agency, but all of humanity, collectively planning for a journey to the new world. Telescopes continued to search and soon found a handful of other promising targets in various directions. A bit farther away, some bigger or smaller, each with its own character. One world had a large moon that might be habitable. Another was a planet around a binary star system, giving it double sunsets. But New Earth remained the crown jewel, relatively close in cosmic terms, seemingly with clement conditions and with possible life. The more we learned about these exoplanets, the more we realized how special Earth itself is, and yet how many variations nature can create. Some planets were covered entirely in ocean, water worlds where life, if present, might only be aquatic. Others were drier, but had oasis regions near cool poles or warm equators. There were also cautionary tales. A planet a little larger than Earth, with too thick an atmosphere, turned out to be a hothouse, perhaps like a supersized Venus, with choking clouds. Another orbiting a young star showed a barren surface, pockmarked by asteroid impacts. Its youth making it a dangerous neighborhood. Not every Earth-like in size is truly Earth-like in environment. Thus, Earth 2.0 wasn't just any Earth-sized planet. It was a carefully vetted choice. The starship builders and mission planners evaluated everything: the length of the journey, the data on climate and resources, even the star's future stability. They wanted a star that wouldn't go berserk on its planets with flares, or start to die off for billions of years. New Earth checked many boxes. It was a bit different, maybe slightly higher gravity, maybe its day was a bit longer, maybe it had 2 small moons instead of 1 big moon. But overall, it was a place humans could imagine living. Before departure, people on Earth held events akin to ancient explorers' farewell ceremonies. There might have been a day when across the world, at observatories and public squares, citizens gathered to watch New Earth's star rise or set, with aid of telescopes or giant display screens, waving in symbolic gesture toward that distant light for good luck and future greetings. Songs were written about the new world, and children in school would point at a star map and know that's where the starship is heading. Back in the realm of science and engineering, final preparations were underway. The crew chosen for the journey trained intensely. They studied everything known about New Earth. Geologists speculated on its rock formations from spectral data. Meteorologists modelled its climate. Biologists prepared protocols for studying whatever life they might find there without harm. Meanwhile, life support systems were tested and retested to mimic what conditions might be like using the real air and water chemistry expected on New Earth. They even adjusted some of the ship's ecological systems to better match what the colonists would encounter. For instance, if the soil there was a bit different mineral mix, They grew some crops in similar soil in test greenhouses to ensure they would adapt. This search and preparation phase lasted many years, but at last, both the target and the means of getting there aligned. The day came when the great Ark ship, loaded with its supplies, knowledge, and hopeful souls, launched from Earth orbit, slowly gaining speed and departing our solar system. It was aiming for that pale star in the night that humans had studied and yearned for from afar. Now, as we return to our journey's narrative, we imagine that starship finally arriving in the new Earth system after its long voyage. The people aboard, generations removed from those who first saw the images and data, are about to see the planet with their own eyes. All the searching, dreaming, and planning has led to this moment. Humanity reaching an alien yet strangely familiar shore. The new world awaits, with all its beauty and challenges under an alien sun. A new sun climbs above the horizon, not the sun that rose over humanity for millennia, but an alien sun, casting its unfamiliar glow across alien landscapes. Under this golden-hued morning light, the first human colony beyond our solar system stirs to life. On a broad plain near the edge of a turquoise sea, a cluster of habitats stands, shiny, dome-like tents and sturdy prefabricated structures brought from the starship. Smoke curls gently from a chimney where a generator hums, and a heater keeps the chill of the alien dawn at bay. Surrounding the camp are strange vistas, trees with fern-like fronds of a dark purple colour, swaying in a gentle breeze. Rock formations in the distance tinted with red minerals, and two pale moons still visible in the sky from the night, one larger with a faint ring around it, the other a smaller, cratered companion. Today is a historic day. It marks 1 year since planetfall, since the generation ship arrived and humans set foot on this new world. Much has happened in that time. Initially, the crew orbited the planet for several weeks, surveying and selecting a safe landing site. They chose this coastal region for its moderate climate, abundant water, and a large flat area suitable for touchdown. When the lander doors first opened, the colonists stepped out in protective suits. Cautious of the unknown biosphere, they moved slowly, testing air and soil. To their relief, the atmosphere was breathable, a little higher in oxygen than Earth's, making them feel slightly lightheaded at first, but nothing their bodies couldn't adapt to. The temperature was mild, akin to a spring day on Earth, and the gravity, as expected, was just a touch heavier. You could feel it when you jumped. Not that they did much jumping in heavy suits with gravity slightly higher than what they knew. The first human foot pressed into the reddish soil, leaving a print that would perhaps last until the next rain. In that moment, cheers erupted over the radio. People cried tears of joy inside their helmets, their voices trembling as they spoke words that would be recorded in history. One of the mission leaders planted a flag, not of any single nation, but a flag symbolizing Earth and all humankind. Others set up scientific instruments to immediately begin analyzing the environment. A small drone was released into the air, buzzing off to capture panoramic views of this alien vista. It confirmed what they could already see with their eyes, a world both hauntingly strange and strikingly beautiful. At first, the colonists established a secure base. They lived out of the lander and temporary shelters, while constructing more permanent habitat modules. They erected inflatable greenhouses and filled them with earth, soil, and seeds that had been carefully carried across the stars. A power station was set up. Solar panels unfolded to drink in the sunlight, slightly more orange than back home, but plentiful. And a compact fusion reactor was activated to provide steady energy through nights and cloudy days. Water was plentiful. A nearby river, fed by mountain springs, meandered not far from camp, and they set up a treatment plant to ensure it was safe to drink. As days went by, and no harmful microbes felled them, the colonists cautiously shed their suits within the base perimeter, eventually walking freely under the alien sky, feeling the breeze on their skin, a breeze that carried subtle new scents, perhaps from those purple ferns, or the alien blooms in the grasses. There were indeed native life forms, primarily plants and simple animals, akin to insects, and small amphibian-like creatures near the water. The colonists often felt like they were children, tiptoeing in a pristine garden. They took great care with every step, every sample. Biologists worked in excitement and with reverence, cataloguing species, taking images and notes. They found that the purple hue in plants came from a pigment not unlike chlorophyll, but tuned to absorb the star's light, which leaned towards the red part of the spectrum. The alien plants performed photosynthesis, releasing oxygen, confirming that, yes, local life was a major contributor to the breathable air. In the tide pools by the shore, they marveled at something like seaweed waving in the water and small shelled creatures clinging to rocks. Life here was different in form, but familiar in function. It still built shells from minerals, still used proteins and complex molecules to thrive. Preliminary tests showed that while the biochemistry had unique twists, it shared some basic amino acids and structures with Earth life. The biologists pondered whether this was convergent evolution, or if perhaps the ingredients of life naturally push it in similar directions anywhere. The colonists knew not to eat any native plants or animals. That could be dangerous, as the biochemistry might be incompatible or even toxic. They relied on their own food stores and crops from earth plants that they cultivated in greenhouses and eventually in prepared plots of local soil. Interestingly, some earth plants took to the alien soil eagerly, as it was rich in nutrients. Others struggled, needing adjustments to the soil pH or the introduction of earth microbes to help their roots. Bit by bit, they coaxed a little bit of earth to grow on alien land. Rows of wheat and vegetables sprang up next to groves of fruit saplings. Seeing an apple tree blossom under an alien sun moved many to tears, a symbol that a piece of earth was now alive here too. As the colony became more established, they ventured further out. They mapped the nearby region. There were rolling hills to the west, full of the purple fern forests. To the east, the sea stretched out, and they could see spouts of water in the distance, suggesting large aquatic creatures occasionally breaking the surface. To the north, beyond the river, rose majestic snow-capped mountains, and to the south, open plains shimmered with grasses under the twin moons at night. The variety of environments promised that this world could host a rich tapestry of life and many possible sites for future settlements. Every evening, the colonists would gather to watch the sunset. This became a cherished ritual, Their star set a bit more slowly than the sun back on Earth, due to the planet's slightly longer day. The sky would light up in deep oranges and purples. When the sun finally dipped below the horizon, the afterglow would linger, and then, one by one, the stars would appear. How different the constellations were. From here, even the familiar ones from Earth were distorted or unrecognizable. The Milky Way's band still arched across the sky, but seen from a new angle. And among those stars was one particular star, not particularly bright, but singular in meaning. The sun, their ancestral home's star. The colonists knew just where to find it thanks to star charts. Some nights they would point a telescope at that star and reflect on the fact that around it, tiny and distant, was Earth, the cradle of humanity, shining faintly. Perhaps, in that moment, someone on Earth was looking back in the direction of New Earth's star, wondering about them. The colony had its challenges too. They experienced their first fierce storm and realized that the rain here was slightly acidic. Something in the atmosphere, perhaps volcanic activity on the planet, led to stronger carbonic acid in the rainfall. They adjusted by adding protective coatings to structures. They also dealt with an illness when a few colonists came down with allergic reactions to pollen-like spores from a local plant. The doctor treated them and adapted filters for the habitat's air systems. These episodes were reminders that even a welcoming world has its own dangers and unknowns. Days on New Earth were filled with work, constructing more facilities, conducting science, expanding livable space. But the colonists made time for culture too. They celebrated Earth holidays, but also started new traditions. The day of landing was now Landing Day, a new holiday for this world. On that day each year, they hold a gathering by the original landing site, where a plaque lists the names of the crew and the date of arrival. They give thanks for the journey and for the chance to begin again under these alien skies. Music created here has started to incorporate the sounds of the environment. One colonist, a musician, recorded the haunting calls of nocturnal creatures and the rhythm of waves on the shore, mixing them into songs played on earth instruments, creating a blend of two worlds in melody. Children have been born on this world too. The first baby born under an alien sun was delivered just months ago, a healthy little girl. Her parents named her Dawn, symbolizing the dawn of a new chapter for humanity. Baby Dawn will grow up never having seen Earth, running through fields of two-tone grass and perhaps climbing purple-leaved trees. She'll learn about Earth from stories and images, much like the generation ship children did. But her playground is a real planet, with a vast sky and horizon. She is the first of a new generation that will truly call this place home. Watching her giggle at the sight of fluttering alien butterfly-like insects is a joy to everyone. It means humans are not just surviving here, but thriving and growing. As the colony solidifies, thoughts turn to the future. This settlement is just the beachhead. The starship that brought them may be refurbished as a habitat in orbit or used to ferry people and resources to other parts of the planet. Plans are drawn to explore the far side of the planet, to set up a second outpost by a large lake spotted from orbit. There is even talk of building a research station on one of the moons to study the planet and stars from a different vantage. communication arrays have been set up to send messages back to Earth, though those messages take years to arrive. Still, they dutifully send updates, hoping to one day receive a reply from people they left behind, perhaps from children who grew up after they departed, now adults hearing the crackling broadcast from a world 12 light years away. The Colonies scientists also prepared a beacon, a kind of lighthouse signal in radio form, to let any listening intelligences know that humanity had arrived on New Earth. It's a gentle, coded message, containing basic information about humans and our origins on Earth, transmitted periodically into the stars. Most assume it will simply travel forever without being received, just a symbolic gesture. But it reflects a profound shift. Humanity is now not just looking for evidence of others from the safety of Earth, but announcing its presence in another star system. Under the alien suns, for the second smaller sun of the binary system, if the star has a companion, occasionally graces the daytime sky as a bright star. Humanity's first interstellar colony stands as a testament to curiosity and courage. At night, around a campfire outside the main habitat, a few colonists gather and share stories. They talk about how, long ago, their ancestors looked up from African savannas at unfamiliar stars as they migrated to new lands. Now humans have migrated farther than ever, but the age-old act of sitting together, telling stories under the stars, continues. The firelight dances in their eyes as one elder, one of the few who was actually born on the generation ship, now greying, recounts the journey and the sacrifices that were made to get here. The younger ones listen intently, imagining in their minds the great ship ploughing through space that they themselves never saw, having been born after arrival. One story flows into another, and inevitably they speak of the possibilities the future holds. If life could take root on two worlds independently, Earth and this planet, what of the countless other stars out there? Are there other intelligences looking up at their skies, wondering as we do? Might some far-off civilization see the faint glimmer of our campfire, or catch the murmur of our transmissions? The Colonies astronomer mentions a peculiar signal they recorded a few weeks back, likely just a natural pulsar or a quirk of atmospheric static, but it made their hearts skip for a moment, thinking it could be something artificial from far away. They all exchange hopeful glances and gentle smiles at the thought that, even as they have become the aliens on this new world, there might be others alien to us yet to meet. The night deepens, and one by one, the colonists drift to their beds. The two moons set, and the sky is left to the stars alone. In the quiet, the camera of our mind's eye pulls back. We see the tiny cluster of lights that is the human colony amidst a vast, dark terrain. A little spark of life and industry on a whole planet. We pull back further and see the planet itself, blue and green and red, spinning through space, its new guardians tending a small flame of human civilization on its surface. Around it, the star glows warmly, and far beyond, other stars dot the cosmos. Our journey in this part draws to a close with humanity successfully nestled under an alien sun. Yet, the story is far from over. New Earth is but the first step into a much larger universe. Questions linger in the silence of the night. What other marvels await us among the stars? Who else might be out there, watching the skies, or even watching us? The colony on this world may one day reach out further, launching new explorers deeper into the galaxy. As dawn approaches again, humanity stands at the threshold of an even greater unknown, not just finding new homes, but finding new neighbors in the cosmic ocean. With hearts full of wonder, our colonists and all of us await what comes next as the future of the cosmos continues to unfold in mystery and splendor. In the depths of a starry night, humanity gazes outward and listens. Our radio telescopes sweep the sky with quiet hope, tuning in to the cosmic static for any whisper of a distant intelligence. We have ventured beyond our home world, set foot on our moon, and sent mechanical envoys to the planets and beyond. Yet, as far as our reach extends, we find only silence. The stars sparkle in serene indifference. In this vast universe, filled with countless galaxies and unending voids between, a haunting question echoes softly in our minds. Are we alone? For generations we have asked this question, and for generations the universe has answered with nothing but a great, still silence. It is often called the Great Silence, the eerie quietude in the dark expanse of space where we expected, perhaps even yearned, to hear some sign of others like ourselves. Think of it. Hundreds of billions of stars wheel above us in our galaxy alone, likely trillions of planets circling them, many of those worlds perhaps as warm and welcoming to life as our own Earth once was. By sheer probability, it seems the night sky should be alive with signals and stories, with civilizations reaching out across the light years. And yet, night after night, year after year, our instruments detect no deliberate beacon from any distant world. At first, this silence might appear to be an answer in itself. One could stand under the vault of the Milky Way, feeling small and solitary, and conclude that perhaps we are alone. But most scientists gently resist that conclusion. The cosmos is simply too vast, the numbers too great, for life to have blossomed only on our tiny world. In the last few decades, astronomers have confirmed that planets abound around other stars. Thousands upon thousands of exoplanets have been discovered, some tantalizingly similar to Earth, orbiting in the temperate glow of their suns, where liquid water and life as we know it could exist. If even a fraction of those worlds have given rise to living organisms, then life might be common. And if on even 1 in 100 of those living worlds, intelligence and civilization arose, the night should not be so quiet. This apparent contradiction between the expectation of cosmic company and the reality of cosmic quiet is a profound mystery. The physicist Enrico Fermi famously captured it in a simple, poignant question. Where is everybody? In a universe so old and so vast, where are all the other voices, the other minds? This question has come to frame our modern musings about extraterrestrial life. We call it the Fermi paradox. By the numbers, by the logic of large numbers and time, the galaxy ought to be teeming with life and even advanced civilizations. Yet our searches have found no evidence of anyone else. It is as if we are in a dark, empty theatre, hearing only our own footsteps and wondering why no one else has shown up to the show. One possible answer to this riddle is that we have not listened long enough or hard enough. After all, our efforts to find signals from other civilizations are still in their infancy. Only within the past century did we even possess radio technology. Our SETI experiments, the search for extraterrestrial intelligence, have only scanned a tiny fraction of the sky across limited frequencies for a brief moment of cosmic time. Imagine standing by the ocean and scooping up a single glass of water, finding no fish in that glass. Would we conclude the ocean is empty? Of course not. Likewise, the cosmic ocean is vast, and our sampling of it so far has been minuscule. It may be that others are out there, broadcasting signals or beaconing their existence, and we simply haven't yet pointed our antennae in the right place at the right time. The great silence might not be absolute. It could be that the music of other civilizations is playing, but we haven't tuned to the correct channel. Another possibility is that everyone is listening, but no one is transmitting. Perhaps advanced civilizations tend to be cautious, aware that the cosmos could harbor dangers, or simply respecting the evolution of emerging cultures by not intruding. Under this cosmic zoo hypothesis, we might be like unknowing creatures in a wildlife preserve, observed from afar by quiet watchers who prefer not to disturb our natural development. It is an unsettling thought that aliens could be out there, maybe even nearby, silently observing us the way we watch animals in a forest, careful not to startle them. If true, the silence would be intentional, a kind of quarantine until we reach a certain level of maturity or technological ability. So far, however, this idea remains pure speculation, with no evidence that anyone is secretly keeping tabs on humanity. There is also the notion of the universe as a dark forest, a metaphor drawn from a haunting work of fiction. In a dark forest at night, every creature moves cautiously, trying not to reveal its presence, because predators may lurk unseen. Applied to the cosmos, this idea suggests that perhaps all civilizations stay quiet out of fear. Fear of attracting attention from something or someone hostile. If every culture thinks it's safer to hide, then none would broadcast signals or announce their existence, and the cosmic night would indeed remain silent. It's an intriguing and somber speculation. Yet, like the zoo hypothesis, it remains only an idea. We have no evidence that the universe harbors a lurking menace, and it would require an unlikely coincidence of caution among all life forms everywhere. For all we know, many beings out there could be peaceful explorers like us, just as curious and just as cautious, or perhaps braver in reaching out. Some thinkers propose that advanced civilizations might not use methods of communication we can detect or even comprehend. Consider how far human communications have evolved in a mere century, from crackling telegraph wires to wireless radio to the complex digital networks spanning our globe. An alien society thousands or millions of years beyond us, may have long abandoned radio waves for technologies we have yet to imagine. Perhaps they converse through finely directed beams of particles or entanglements in quantum fields or channels we cannot even name. To our instruments, their communications would be indistinguishable from the natural background hum of the universe, or entirely invisible altogether. If that is the case, the void might seem quiet to our primitive ears and eyes, while in truth it could be alive with conversations hidden in forms we are blind to. Then again, perhaps there really is no one else, at least not nearby. It's a possibility we must acknowledge. Maybe life, especially intelligent life, is extraordinarily rare. After all, our own Earth spent billions of years populated only by microbes and simple creatures. Only in the last cosmic moment did beings appear who could wonder and build and reach for the stars. It took a chain of countless fortunate events and conditions, a stable planet with just the right ingredients, a protective magnetic field, a steady sun, cycles of extinction and survival, to eventually yield us, the inquisitive apes, with minds enough to ask the question. Perhaps such a perfect set of circumstances comes about only once in a great while. If we are indeed alone, then the great silence is simply the natural state of an empty cosmos, and we have been talking to ourselves all along. Still, many scientists feel that being truly alone is unlikely. It would make us a strange exception in a universe where the laws of nature seem to repeat across space and time. They suspect instead that simple life may be plentiful, while intelligent life could be much less common. Picture a galaxy where countless worlds teem with microbial colonies, alien algae in distant seas, tiny organisms processing chemicals in exotic atmospheres. Yet only on rare occasions does life climb the ladder of complexity towards intelligence. Perhaps there are many planets with gardens and oceans full of life, but very few with cities and spacecraft. In that scenario, the night sky might indeed hold life abundant, but mostly quiet, mindless, or modest life that does not gaze at the stars or send out a call. The intelligent civilizations, if they exist, could be scattered sparsely, separated by such enormous gulfs of space and time that each grows up largely in isolation, like islands in a dark sea. It's also worth considering that even if life and intelligence emerge, the lifespan of a technological civilization might be fleeting on cosmic scales. A society might flourish, communicate, perhaps reach for the stars, and then eventually fade away or transform. This could happen through self-destruction, wars, environmental collapse, or by natural disasters, or even by evolving into forms that no longer use technology recognizable to us. If civilizations burn brightly but briefly, the chances of two existing at the same time and catching one another's signals might be low. We have been a communicative civilization for only a century or so. We cannot know if we will persist for millennia more or snuff ourselves out through folly. If the latter is a common story, a brief burst of radio and rocket activity before silence, then the galaxy might indeed be littered with the quiet ruins or echoes of those who came before, each blinking on and off before others could notice. These contemplations can feel melancholy, painting a picture of a lonely or perilous cosmos. Yet within them lies a message of urgency and responsibility. If intelligent life is truly rare, then the survival of our own civilization carries added weight. We might hold a unique treasure, the only known consciousness able to reflect on the universe. The great silence then becomes a gentle admonition to cherish and protect what we have, our planet, our people, and the fragile spark of awareness within us. For if we are one of the few lights shining in a vast dark, how tragic it would be to extinguish ourselves and leave the universe in silence once more. On the other hand, if we are not alone, then the silence is a mystery we are driven to solve. It means the cosmic chorus has other voices, and we simply haven't heard them yet. Each new leap in our technology might bring us closer to detecting that faint murmur in the dark, the first hint that the silence is not absolute. Every year, astronomers develop more sensitive instruments, listening across broader bands of the spectrum, peering deeper into space for subtle signs. We examine starlight for unusual fingerprints, perhaps a mix of gases in a far-off planet's atmosphere that could only be produced by living creatures. We monitor for patterns in radio waves or bursts of energy that defy natural explanation. Hope remains alive in the quiet nights. Hope that one day we will stumble upon a sign that says, unmistakably, we are not alone. And so, we continue to listen. We listen with patience and with wonder. Our radio dishes turn to the sky like great open ears, and our optical telescopes like vigilant eyes. We also send out our own messages in bottles. A burst of radio waves here, a whisper from a powerful transmitter there. Even physical capsules of our existence hurtling through space. Decades ago, we attached a golden record to a spacecraft destined to wander the stars. On it were the sounds of our planet, music, and greetings in many languages. A friendly hello from Earth to whoever might find it. These are small gestures, almost humble, given the enormity of space, but they carry our longing to connect. Like a lone traveller singing to herself in the dark to feel less alone, we beam our songs outward and hope someone sings back from the darkness. For now, the void between the stars remains mostly quiet. The great silence endures, but silence is not the same as emptiness, and not the same as oblivion. It could be broken at any moment by a simple signal, one lonely bit of code, or a distant melody on the airwaves that reaches our ears and tells us we have company. Until that day, we live suspended between solitude and possibility, our imaginations filling the void with questions. We ask ourselves, are we the only ones who build and dream? The only ones who look up at the stars with curiosity? Or are there others on far-flung worlds, perhaps gazing at their own night sky, eyes or senses turned upward, wondering if someone like us exists out here? Maybe they too stand under alien constellations and feel that same mixture of loneliness and hope. Paradoxically, the great silence itself pushes us to imagine and explore in ways we might not have otherwise. In the absence of answers, we fill the void with possibilities. We dream of what other life forms might be like, how they might appear or behave, what senses they could have, what environments they call home. The silence is like an open canvas, and on it we paint countless scenarios of alien life. It challenges us to broaden our definition of life, to ensure that when we search, we do not overlook a form of life just because it doesn't fit our preconceptions. If we want to truly answer whether we are alone, we must be prepared to recognize life, even if it comes in forms utterly unfamiliar. Life not as we know it. When we speak of life, we can't help but picture the forms we know, the creatures of Earth with their familiar biochemistry. But the universe may have countless ways of assembling the phenomenon we call life. It's entirely possible that if we were to encounter alien biology, we might at first not even recognize it as living. Life as we know it is carbon-based, water-dependent, and built from the same handful of molecular ingredients across every organism on this planet. Yet beyond Earth, life could take on forms that challenge every assumption we have. In our imagination, we must venture beyond the comfortable and the familiar, to conceive of life not as we know it. All life on Earth, from the tiniest microbe to the grandest redwood tree, shares a common chemistry and ancestry. We are all cousins under the skin, so to speak, using DNA and RNA to carry genetic information, using proteins as our workhorse molecules, and relying on liquid water as the medium for our chemistry. This unity is beautiful, but it can also blind us to other possibilities. If we find life on another world, it may not play by our rules. Perhaps it uses a different molecule to carry instructions, something other than DNA. Or maybe its chemistry is based on an element besides carbon, silicon, for instance, forming a backbone for life in a way that carbon does for us. Silicon-based life has long been a topic of speculation. After all, silicon is abundant in the universe, and chemically somewhat similar to carbon. One could imagine creatures whose cells are made of silica, living at temperatures that would melt an earthly organism, their biochemistry moving at a slow, geological pace. In the searing heat near a volcano's vent, or the crushing pressure deep beneath a planet's crust, perhaps silicon life could thrive. Instead of water, maybe such organisms use liquid methane or ammonia as a solvent for their biology. Fluids that would be poisonously cold for us, but just right for chemistry in those alien cells. To our eyes, accustomed to the quick, water-based life of Earth, these beings might seem more like moving rocks or crystal formations, growing and reproducing over centuries. Consider also the possibility of life that floats in clouds or swims in oceans of exotic liquids. Our own planet teaches us that life can flourish in water, but elsewhere it might find a home in seas of methane, ethane, or even stranger concoctions. On Saturn's moon Titan, for example, there are vast lakes of liquid methane and ethane under a thick, golden haze. Titan is unimaginably cold by our standards, with a surface temperature nearly 180 degrees Celsius below zero. Yet scientists have pondered whether chemistry in that frigid darkness might still yield living systems. Any life on Titan would be very different. It might incorporate antifreeze-like chemicals to stay flexible and breathe not oxygen, but maybe hydrogen, exhaling methane in turn. It would be life in slow motion, its metabolism sluggish in the cold, but life all the same. A dance of complex molecules exchanging energy and information. Meanwhile, at the other extreme, picture a world so close to its star that rock boils and oceans are unknown. Could there be living things in such an inferno? Perhaps not in forms we easily imagine, yet science fiction has dared to dream of plasma-like creatures in stars or energy beings that inhabit the magnetic fields of gas giants. These ideas stretch the meaning of biology to its limits. If a thing has no cells, no defined body at all, can it be alive? Maybe the definition of life itself would expand if we met entities that thrive in stars or the void of space, feeding on cosmic radiation or solar winds. Such speculative life forms might be beyond our ability to detect or understand right now, but they remind us not to set boundaries on Mother Nature's ingenuity too hastily. Closer to home, and perhaps more plausibly, we look to worlds like Mars or the icy moons of Jupiter and Saturn for hints of exotic life. Mars, cold and desert-like, once had flowing rivers and lakes. If life took hold there long ago, it might persist today in hidden niches, maybe as microbes dormant in the permafrost, or clinging on in salty brine seeps that stay liquid in the winter. If we discover even a simple bacterium on Mars that has a different origin than Earth life, it would revolutionize our understanding. Two independent origins of life in one solar system would suggest life springs up readily wherever conditions allow. Conversely, if we search Mars thoroughly and find nothing alive, it might imply that even Earth's simple beginnings were a rare fluke. Farther out, Jupiter's moon Europa and Saturn's moon Enceladus are tantalizing. Beneath their thick shells of ice lie global oceans of liquid water, kept warm by tidal forces flexing their cores. On Earth, we have found rich ecosystems clustered around hydrothermal vents on the ocean floor, where sunlight never reaches, but life thrives on chemical energy from the planet's interior. Europa and Enceladus likely have similar vents at the bottom of their dark seas, spewing mineral-laden water. Could strange marine creatures glide through those alien oceans, completely cut off from the surface and sky? Perhaps tube-like worms, translucent fish analogues, or entirely unearthly things unlike anything we've seen, all feeding on the heat and nutrients from the moon's inner hearth. We have even caught a glimpse of Enceladus's secrets, geysers jetting from its south pole that contain organic molecules. It's as if that moon is whispering hints that life could indeed hide under its icy crust. What about life that is utterly alien, not just in chemistry, but in form? Imagine creatures that share no resemblance to animals or plants. They might be enormous colony organisms, like sprawling mats or networks that cover acres of ground, acting with one mind across their entire expanse. Or they could be microscopic collectives, swarms of tiny units that only together form a conscious whole. We can look to Earth for inspiration. The Portuguese man of war looks like a single jellyfish, but is actually a colony of specialized creatures working in unison. Slime molds live as single cells most of the time, but sometimes gather into a moving slug-like entity when food is scarce, almost like a temporary multicellular creature. If evolution can do that here, on another world, it might have gone further, blurring the lines between individual and colony until the very notion of an individual organism is meaningless. Consider intelligence arising in such a collective form, a mind composed of many small parts. On Earth, the closest might be a beehive or an ant colony, where no single insect is intelligent on its own, but together they achieve remarkable feats, as if guided by an unseen collective mind. An alien civilization could, in theory, be not individuals like us, but swarms. Intelligence distributed in countless tiny agents that communicate constantly. Their bodies might be entire ecosystems or cloud-like shoals drifting in an atmosphere. To us, they would be alien indeed. One might greet not a single being, but an amalgamation of many, thinking as one. This kind of life might have very different concepts of identity and society, rooted in their biology. Even the senses of alien life could be far beyond our experience. Earth's creatures sense the world in a limited number of ways: sight, hearing, touch, taste, smell, plus a few specialized senses like echolocation or electroreception in certain animals. But an alien life form might perceive magnetic fields visually, or taste colors, or have senses we lack words for. Imagine a being that navigates by the polarization of light, or one that can detect the subtle curvature of space-time. There could be creatures that see not just the rainbow of visible light, but far into infrared or ultraviolet, painting a picture of their environment utterly unlike the one we see. Some life might live its entire existence in darkness, deep underground or underwater, and rely on touch and chemical cues as the primary channels of information. To communicate, such creatures might use flashes of bioluminescence, or vibrations, or complex pheromones in the air or water. If we encountered them, understanding their language might first require understanding senses we ourselves do not possess. To prepare for these possibilities, scientists are broadening their minds and their experiments. Astrobiologists talk of searching for agnostic biosignatures, signs of life that don't depend on knowing the specific chemistry. They look for things like imbalance in a planet's atmosphere, unusual ratios of gases that could indicate something breathing or metabolizing, even if it's not oxygen or carbon dioxide as on Earth. They study the fundamental patterns of life, the way energy flows and builds order from chaos, to see if there are universal markers that scream life, regardless of form. For instance, one might search for complex organic molecules arranged in patterns unlikely from random chemistry alone, or for structures that repeat and contain information, akin to how DNA encodes information here. On Earth, we've discovered living things in places we once thought completely barren. Microbes have been found deep beneath the ocean floor, inside rocks heated by magma. Bacteria thrive in acidic lakes and in water nearly boiling from geothermal heat. Some organisms endure inside nuclear reactors, bathed in radiation that would kill humans swiftly. Tardigrades, tiny water bears, smaller than a grain of sand, can survive the vacuum of space, extreme cold and heat, and crushing pressure by entering a near-death dormant state. Each time we find life in an extreme environment, it expands our notion of what is habitable. It gives us confidence that life beyond Earth might endure in places very unlike the gentle conditions we enjoy on our planet's surface. Even so, finding life out there will be challenging. We have to recognize it for what it is. If it's microbial, we might need to dig into ice or soil to find a few cells or subtle chemical traces. If it's something like a fungus or algae, we could mistake it for inert mineral deposits, unless we look closely for patterns or movement. And if it's truly alien in composition, our tests designed to detect Earth-like life might simply shrug and report nothing. A famous thought experiment asks, if we encountered life that wasn't based on cells or familiar molecules, would we even know it was alive? We might need to rely on more fundamental criteria. Does it consume energy and maintain some internal order? Does it grow or reproduce or respond to its environment in complex ways? These are the hints that something is alive, even if it looks like a weird sludge or a shimmering cloud. As our probes and telescopes investigate the planets and moons in our solar system, we are also beginning to probe the atmospheres of planets around other stars for signs of life. The light filtering through an alien planet's sky can carry faint fingerprints of the gases there. By splitting that light and analyzing it, we might detect, say, a lot of oxygen or methane in the air, gases that on Earth are replenished by life. One day, perhaps soon, we may find such a signature in the spectrum of a far-off world, a clue that something is alive on its surface or in its oceans. It won't tell us what the life looks like, only that it has altered its planet in a way we can perceive from across light years. But that would be enough to know life has arisen elsewhere, that we are no longer alone in a biological sense. Our imaginations, however, go further than microbes. We wonder about larger organisms on those distant worlds. Will they have limbs and eyes and faces, or take shapes we would find bizarre? On a high-gravity planet, maybe life stays low and strong, squat, sturdy forms that hug the ground. On a low-gravity moon, perhaps creatures grow tall and spindly, or even float through the air with broad wings, since flying would be easier there. In the dim red glow of a dwarf star, photosynthetic life might have nearly black foliage to soak up the meager light, painting alien landscapes in charcoal hues. On a world with ceaseless strong winds, perhaps tree-like organisms are supple and ribbon-like, streaming with the gales rather than resisting them. Each environment will shape its life uniquely, just as Earth's diverse environments have shaped the creatures here. From the deep-sea fish, with their ghostly lights, to the camouflaged insects of the forest. The potential diversity of life is as vast as the cosmos. Perhaps somewhere there are beings that eerily resemble creatures from our own myths, something like the dragons or angels of story, recognizable forms that make us gasp. But it's just as likely that real aliens will astonish us with forms no one ever anticipated. They might be beautiful in ways we can't imagine, or unsettlingly strange, or both at once. They might not fit into any category of plant or animal, or they might blur the line between biology and machine if evolution or design has merged the two. They may even challenge what we define as life. Whatever they turn out to be, finding even one instance of alien life will fundamentally change our relationship to the cosmos. It will mean that the spark of life is not a lonely flame on one world, but part of a larger tapestry. For now, this remains the province of imagination and theory. We have yet to discover even the simplest alien microbe, but the very possibility of life, not as we know it, has already broadened our minds and our science. We're learning to step outside our own perspective and consider biology from the ground up as something that could manifest in unearthly ways. With each rover that scoops Martian soil, each probe that tastes the spray of Enceladus's geysers, each new telescope scanning a distant planet's skies, we are asking the cosmos, what other forms can life take? In our labs, some scientists attempt to brew artificial life with novel chemicals, trying to anticipate what nature might have already done on another world. All of this prepares us for that day, perhaps decades or centuries ahead, when we finally come face to face with life beyond Earth. It might be a humble microbe in a microscope view, but it will speak volumes, telling us that life is not unique to our world, and that nature's inventions are more wondrous and varied than we dared hope. If life can arise throughout the cosmos in myriad forms, then the next question follows. Can intelligence also arise in those far-flung worlds? Here on Earth, it took an extraordinary confluence of circumstances and a vast stretch of time to produce creatures capable of thought and technology. If elsewhere, evolution has given rise to thinking beings, they might be utterly unlike us in body and perhaps in mind. Imagining alien biology naturally leads to imagining alien intelligence. What would other minds be like? What kinds of civilizations might they build under foreign suns? From pondering alien life, we turn now to pondering alien minds, other civilizations that may share this universe with us, shaped by their own worlds and histories. If life beyond Earth has bloomed into intelligence, what alien minds might be gazing back at us across the cosmic void? We can scarcely imagine the varieties of thought and consciousness that may exist, shaped by environments and evolutions utterly unlike our own. On Earth, only one species, our own, developed advanced technology and civilization, but we share this planet with other clever beings, dolphins and whales with complex social lives, primates that use tools, birds that solve puzzles, even octopuses with uncanny problem-solving abilities. These examples hint that intelligence can take many forms, even under Earth's familiar conditions. An alien world could harbour minds as different from us as those creatures are, or even more so. Their senses, instincts, and ways of thinking might be difficult for us to comprehend, at least at first. Yet, if they have built civilizations, we know they share one crucial trait, a spark of curiosity and ingenuity that propelled them beyond mere survival into the realm of knowledge and invention. How common is this spark. For ages, we only had our own story to consider. Life on Earth existed for billions of years, before anything arose that could contemplate the stars. It took a chain of improbable events, the right physical form, the right environmental pressures, for our ancestors to develop high intelligence. Perhaps on most worlds, life stays simple or animal-like, never leaping to that strange self-aware, tool-making stage. Or perhaps intelligence emerges in many places, but not always in a form that leads to technology. Imagine an ocean planet where the smartest creatures are akin to dolphins. They might have rich thoughts and language, but without fire or hands, they may never forge metal or launch rockets. They could form an intelligent society in their seas, singing complex songs. Yet we from afar would detect no cities or radio signals, their brilliance hidden beneath waves. So it might be that the galaxy teems with minds that think and feel, but only a few ever build machines or seek contact across space. When we do consider those who might build civilizations, we have to open our minds to paths very different from humanity's. On Earth, our journey included learning to make fire, inventing tools, agriculture, cities, and eventually electronics and rockets. An alien civilization might have followed a completely alternate route. If their world has different challenges, their priorities and inventions could diverge wildly. Think of a species that evolved on a planet with scarce metals. Perhaps they became master chemists instead of metallurgists, finding ways to create plastic-like materials from organic resources to build their cities. Or a species living under perpetual cloud cover might never see the stars until they develop science. Their early mythology might imagine a closed universe of mist and lightning. If they eventually learn of the cosmos beyond, how astonishing that revelation would be for them. Alien minds might also not share human emotional drives. They could be more serene or more volatile, or guided by completely different instincts. One civilization might be cooperative and harmonious because its species evolved as social herd animals that survived by working together. Another might have a more competitive or aggressive streak, having evolved from predators. Our own history has seen both conflict and cooperation drive innovation. Other civilizations may have different balances. Some might have no concept of war, advancing steadily through communal effort, while others might only unify once they realize the folly of conflict. When we imagine first meeting aliens, we often project our own psyche onto them, fearing hostile invaders or hoping for wise benevolence. The truth could be more complex and more interesting. They will have their own nature, shaped by millions of years of evolution and culture on a world we can scarcely envision. We should also ponder the scale of advancement these civilizations might achieve. Some could be only a bit ahead of us, having perhaps just begun exploring space or communicating over long distances. Others might be far older, their technology so advanced it appears miraculous to our eyes. Imagine a society that had a 1,000,000-year head start on us. They might have mastered forms of energy and matter manipulation that we can only dream of. They could perhaps build gigantic structures, rings encircling their sun to capture its energy, or entire habitats floating in space hosting billions of individuals. They might have solved diseases, aging, maybe even conquered the need for biological bodies at all, existing as conscious software in machines or networks. To us, such beings would be as incomprehensible as a rocket ship would be to an ancient human. Yet, they too would have once been biological creatures starting out, curious about their universe. In their long history, they might remember being as we are now, just taking first steps into the cosmic ocean. When scientists think about advanced civilizations, they sometimes categorize them by energy usage. A youthful civilization like ours is Type 1, using the resources of its home planet. More advanced might be Type 2, harnessing the energy of their entire star, perhaps via those megastructures like immense solar collectors. Beyond that, a Type 3 could tap the power of an entire galaxy. Whether any civilization truly reaches such heights, we do not know. But these categories broaden our perspective on what might be possible. If somewhere out there, a civilization has achieved even Type 2, their engineering feats might be detectable across light years. Yet so far, we have not clearly seen such signs. Perhaps they are rare, or perhaps, as some speculate, truly advanced beings might camouflage their energy use or find more subtle ways to live among the stars. It's also conceivable that as civilizations grow advanced, they may change in fundamental ways. They could merge with their own technology, blurring the line between biological life and machine. We ourselves see the first steps of this in our use of computers and artificial intelligence. An alien society might eventually create AI minds far smarter than their original species, or they might upload their consciousness into digital form to live within virtual worlds or durable machines. If such beings exist, the ones we might encounter could be these engineered intelligences, perhaps traveling the stars long after their biological creators are gone, or evolved into something else, a quiet probe drifting into our solar system someday might carry not little green beings, but a super intelligent computer mind, awake and curious, sent to examine new frontiers. The range of possibilities for alien civilizations is both exciting and humbling. They might be utopian or struggle with problems akin to ours. They might be solitary sages or members of vast communal networks. They could revere nature or see themselves as masters of it. And for all this speculation, it could also be that intelligent societies are exceedingly rare, that we might be among the first. In that case, the cosmos might largely consist of young civilizations, like ships passing in the night, too far apart in space and time to meet easily. Yet even if that's true now, given enough eons, some will eventually collide or connect. The distances between stars are immense, but not unbridgeable for a determined and advanced culture. With patience, generation by generation, they could spread outward. Some might choose to remain in splendid isolation, content with their own star system, while others might be explorers at heart. Whether alien civilizations are plentiful or scarce, primitive or godlike, the possibility of their existence transforms how we see our own. We realize that we might not be the sole authors of the cosmic story. There could be chapters written in entirely different languages of life and mind out there. Somewhere, a far-off civilization might be staring up at their stars, perhaps with their own questions and hopes about neighbours in the cosmos. If one day our paths were to cross, it would be a momentous meeting of minds. For now, these other minds remain hypothetical, distant whispers in our imaginations. But as we continue to search the skies and send out our own signals, we inch closer to the day we might discover we are not alone in having built a society among the stars. What then? How would we greet another intelligent species? And what would the experience mean for both sides? That thought leads us to one of the most profound questions of all, the scenario of first contact, meeting our galactic neighbours for the very first time. Imagine the moment we realise we are not alone. It might begin quietly. A group of scientists hunched over data late at night notice a signal unlike any natural cosmic noise. A simple sequence of pulses emanating from a star many light years away, repeating in a pattern that could only be deliberate. At first, there is doubt. Could it be a glitch or human interference? The team double checks, calls in other observatories around the world to listen. When confirmation finally comes, awe and exhilaration spread through the scientific community. Then, to the public, we have detected a message from another civilization. After generations of gazing at silent stars, we hear a whisper from an alien mind. In that instant, everything changes, and yet everything remains the same. The stars still shine, the world still turns, but humanity's sense of itself is transformed. First contact could also unfold in other ways. Perhaps one day, far in the future, our astronauts exploring a distant planet stumble upon unmistakable signs of an alien outpost or artifacts left behind. A moment of discovery akin to an ancient explorer finding traces of another tribe over the horizon. Or, in the most dramatic scenario, we look up and see a ship entering our skies, a visitor from beyond Earth making the journey to meet us face to face. This scenario has long been the subject of both dreams and nightmares. Would they come in peace, extending a hand or appendage of friendship? Or would they be motivated by needs or intentions we can't fathom? Our imaginations have painted both utopian meetings and catastrophic invasions, but reality is likely to be more nuanced. Any civilization capable of reaching us across the stars would be advanced beyond our comprehension. Perhaps that very maturity would incline them toward caution and curiosity rather than conquest. If the first contact comes in the form of a communication, a message exchanged across the void, it may unfold slowly. Consider a radio signal from dozens of light years away. Once we receive it, and perhaps send a reply, decades could pass before we hear back due to the vast distances. The initial message might be simple or incredibly complex. It could take years just to decipher its meaning, especially if it's not designed specifically for us, but rather a beacon announcing their presence. There would be a global effort of minds coming together to unlock the code, to figure out how to say hello in a language born on another world. Meanwhile, Humanity would be buzzing with excitement. Every news outlet, every conversation might revolve around the discovery. What are they like? What are they saying? In schools and homes, people would look at the night sky with new wonder, knowing that there are others out there, no longer purely a matter of conjecture, but an established fact. History on Earth gives us both hopeful and cautionary tales for first meetings. When isolated human cultures encountered each other, the outcomes ranged from fruitful exchange to tragic misunderstanding and conflict. The lesson is that first contact is delicate. Without a common language or frame of reference, even friendly intentions can be misread. When humans meet wild animals, sometimes fear and confusion can lead to aggression on either side, without anyone meaning harm. With aliens, the gulf of understanding would be vastly wider. We would have to approach with great care, and so would they. Perhaps they would observe from a distance, study our languages and behavior through our broadcasts before ever directly addressing us, to minimize the chance of a misstep. In turn, we would need to manage our own fears and hopes, to greet them calmly and openly, rather than with panic. One can imagine the United Nations, or a similar body, convening in an emergency session upon confirmation of a contact. Nations that often disagree might quickly find common ground in the face of something truly novel. Humanity's first interaction with an extraterrestrial intelligence. Experts in science, language, diplomacy, and ethics would gather to formulate a response. What do we say to beings who come from another star? Do we represent all of Earth as one, setting aside our differences? Likely yes. In this moment, the existence of them can make all of us feel more like a we, all passengers on spaceship Earth. Long-standing conflicts might suddenly seem trivial as our perspective broadens. That is one of the potential gifts of first contact. It could unite us with a sense of shared humanity as we present ourselves to the cosmos. If the contact were face-to-face, say a ship lands or approaches Earth, the practical considerations would be enormous. We might worry about biological contamination. Germs exchanged between worlds could be as dangerous as any hostile intent. So any physical meeting might start with quarantine and careful protocol, much like scientists sterilizing spacecraft to avoid contaminating other planets. The first actual meeting might be through glass or at a safe distance, with cautious waves or gestures before trust is built. Think of astronauts greeting each other through their helmets. Eventually, perhaps, a direct encounter. Humans and aliens in the same room or space, attempting to communicate. It would be a moment in history like no other. Two intelligent life forms, evolved on different worlds, looking into each other's eyes, or whatever sensing organs they have, and realizing neither is alone in the universe. The cultural and psychological impact of first contact would be profound. Some people might struggle with their worldviews. For instance, certain religious or philosophical beliefs might need to expand to accommodate extraterrestrial life. Others might find their beliefs affirmed, seeing the encounter as the universe becoming more complete. Art, music, and literature would explode with inspiration from this event, a true meeting of worlds. We might exchange not only scientific knowledge, but also stories, art, and ideals with the newcomers over time. just as travelers from distant lands on Earth once exchanged customs and ideas. We would be eager to learn about alien culture. What do they value? Do they have conceptions of beauty, of music, of love and friendship? And what might they learn from us in turn? Of course, caution would remain necessary. We would tread slowly, always ready to pull back if something seemed amiss. But assuming both sides approach with goodwill, or at least neutrality, the relationship could gradually build. Perhaps ambassadors would be exchanged, maybe not in person at first, but via communication links. Humans designated to speak for Earth, and aliens speaking for their people. Trust, once established, could lead to collaborative endeavors, sharing scientific knowledge, maybe a joint exploration mission, or simply a peaceful exchange of messages that enriches both civilizations. The timeline for all this could be years, decades, or even centuries, depending on distances and how cautious everyone is. But the first contact is the critical turning point, the moment the cosmic loneliness is broken and two civilizations say, "Hello," across the stars. In contemplating first contact, one cannot help but feel a mixture of trepidation and hope. It would be both the end of an age of solitude and the beginning of an entirely new chapter for humanity. For so long, we have sent signals and dreamed of hearing an answer. When that answer comes, we will face challenges in understanding and unity, but also unparalleled opportunities to grow. The first handshake, literal or figurative, with an alien intelligence would echo through the ages as one of humanity's greatest milestones. What we do in those first moments and days could set the tone for a long future relationship. Will it be friendly, curious, respectful? We must hope so, and prepare ourselves accordingly. Perhaps the most daunting hurdle in first contact is not the physical meeting or the confirmation of existence, but the challenge of communication, even once we stand before each other in peace. How do we bridge the gap between minds shaped on different worlds? We will need to find a common language, a way to convey meaning across what could be eons of separate evolution. This is the next great question: how to speak with our galactic neighbours, to share knowledge, thoughts, and feelings. The language of the cosmos awaits, the challenge of communicating with other worlds, which we will explore next. Across the immense gulf of space, once contact is made, the next challenge is saying something meaningful and understanding what is said in return. It's one thing to know someone is out there. It's another to truly communicate with them. How do we begin to speak to a species that evolved under alien stars, with no common tongue or gestures? We cannot assume they share any particular language structure or even sensory mode with us. They might communicate through sounds, or flashes of light, or chemical scents, or ways we haven't yet imagined. Finding a common channel is the first step. Maybe radio waves, if that's how we detected them, or visual symbols, if we meet face to face. From there, both sides would likely try to establish basic reference points. In science fiction and real scientific conjecture alike, mathematics often emerges as the go-to common language. Numbers and simple arithmetic could be our first words across the stars, since one hopes that 2 + 2 = 4 everywhere in the universe. Indeed, many SETI thinkers have suggested starting with mathematics and physics. We might begin by transmitting a series of prime numbers or a countdown to show we understand numbers. We could follow with fundamental constants, the frequency of a hydrogen atom's light emission, the ratios of certain elements, clues that we are referencing universal realities. In the famous Arecibo radio message sent in 1974 from Earth, scientists encoded basic information: the numbers 1 through 10, the elements that make up DNA, a simple picture of a human form, our solar system, and the radio dish that sent the message. They hoped that any receivers would decipher the format and learn a little about us. That message was humanity's first deliberate attempt to speak to the cosmos. Future messages, if we ever craft them or receive them, might use similar strategies. Start simple. Build a common vocabulary step by step. If we find ourselves in conversation with aliens, whether through exchange signals or an in-person dialogue, establishing understanding will likely be a painstaking process. Imagine receiving a message that is clearly structured, but in a completely unknown language. It might look like a sequence of patterns, perhaps representing an alien equivalent of words. We would search for repetitions and correlations. Does this part seem to be a greeting or identifier? Are there symbols that might correspond to numbers or objects? Linguists, scientists, and cryptographers would work together, possibly for years, to decode the first extraterrestrial phrases. Every small breakthrough, identifying a number, figuring out a reference like a star or planet name, would be celebrated. It's a grand puzzle, potentially the most complex translation effort in history. One approach to bridge the gap is to use images or visual representations. If we can exchange pictorial information, that might accelerate understanding. Imagine we send a simple image, perhaps a picture of Earth with the sun, moon, and planets to show our place, or a diagram of a human being. They might reply with an image of their own world or themselves. Visuals could establish a baseline of reality. We both see stars. We both have forms and environments. From there, we could attach labels to the images, showing a tree and indicating what we call it, then seeing what they call it, for instance. This is analogous to how one might start communicating with someone who speaks an entirely different tongue on Earth, by pointing at an object and saying the word for it. In time, a basic dictionary could form. In the case of a dialogue via radio or another medium, perhaps we and the aliens would begin exchanging very simple statements once a channel is open. We are from Earth, third planet of our star. Our star is, then perhaps indicating its position among nearby stars. They might respond in kind with their home and identity. Early messages might consist of scientific data, easier to convey than abstract ideas. We might trade star maps, chemical periodic tables, or simple descriptions of our planet's environments. This would not only verify understanding, but also satisfy mutual curiosity in a safe way. Imagine the moment we receive data about an alien world's atmosphere, or a sketch of some creature from their planet. Real knowledge about an exoplanet, straight from its inhabitants. Likewise, they learn directly from us about Earth's diversity of life, our ocean and continents, our weather patterns. Before words of philosophy or culture, this exchange of factual information builds a foundation of trust and understanding. As communication improves, eventually we would try to express more abstract concepts, perhaps sharing aspects of our culture, art, or history. Here lies another challenge. Things that make sense to us might be perplexing to them. How do we convey the concept of music to a being that does not hear, or colour to one that does not see? We may have to find analogies or entirely new ways to communicate such ideas, perhaps through mathematics or physical demonstrations. For instance, we could send audio recordings of our music, along with the mathematical description of the sound waves, hoping they might interpret the patterns, even if their ears are different. Or we might describe emotions through their physiological effects, though that too assumes they experience emotions in a comparable way. This part of the communication, sharing subjective experience, would be the hardest, likely requiring prolonged interaction, like translation AIs, designed collaboratively by both species. We have some practice, in a way, from communicating with other intelligent species on Earth, and even with our own machines. People have taught sign language to great apes, attempting to bridge the gap between human language and an animal mind. We've managed to establish basic communication with dolphins using sound patterns, albeit in a limited fashion. These experiences show that even with significant differences, some communication is possible if both sides are willing and patient. Additionally, our development of artificial intelligence that can translate human languages or even interpret animal sounds hints that technology might aid in deciphering alien speech. It's conceivable that after initial exchanges, we and our new friends could develop translation devices, algorithms that gradually learn the correspondences between our languages, much like how today an app on your phone can translate from English to Chinese in real time. A future device might one day translate human to alien once enough data is gathered. Still, beyond exchanging information, communication is about creating understanding and relationship. True communication means we're not just swapping scientific facts, but actually connecting mind to mind in some way. Understanding intentions, humour, empathy. That level may take a very long time to achieve, perhaps generations, and it could redefine what language means. We might even find that meeting another intelligence leads us to think about our own languages and assumptions in new ways. We might find universals in thought, or perhaps realize that some concepts we assumed were natural are very human-specific. Navigating these differences with respect and curiosity will be key. After all, communication is as much about listening as speaking, learning to truly listen to something utterly new. That may be the ultimate lesson from an alien encounter. Perhaps one day, after long effort, we will sit down with beings from another world and converse, even if through machines or translated symbols. The substance of those conversations will be the true treasure of first contact. We will exchange stories of our respective planets, how life arose, what our challenges and triumphs have been, how we navigate existence. We'll learn each other's philosophies and art. There will be surprises and commonalities. In understanding another species, we will in turn understand ourselves better. Their questions to us might make us reflect on things we took for granted. Their perspectives might solve problems we struggled with, or their mistakes could warn us away from pitfalls. Communication would turn the others into simply new friends, or at least colleagues, in the great enterprise of life. Reaching the point of true communication with an alien civilization would mark a maturity for humanity, a graduation of sorts into a wider community. Even the attempts and failures along the way teach us patience, humility, and ingenuity. By learning to speak across the stars, we acknowledge that we are not the center of the universe, but part of a vast tapestry of beings. This realization brings into focus the grander perspective of our existence. We started as a single species on a small planet, wondering if we were alone. Through courage and curiosity, we extend our voices outward and finally hear others. In doing so, we begin to see ourselves as one among many, a note in the cosmic symphony. And whether or not we ever find others to talk to, the very act of trying has given us a more profound understanding of our own place in the cosmos. It is that cosmic perspective, the view of humanity against the backdrop of the stars, that we turn to now. Viewed from a cosmic vantage, all our debates, our borders, our eras of history, they shrink into a thin film on the surface of a pale blue planet. Astronauts have often remarked on this overview effect when seeing Earth from orbit, how artificial our divisions seem and how precious our world appears against the darkness of space. Extend that gaze further. Imagine looking at Earth from a nearby star. You wouldn't see nations or people, just a gleam of a tiny ocean world orbiting an average sun. In that view, one understands that humanity is a single family, bound to the same fragile sphere. The cosmic perspective does not diminish us. Instead, it elevates us by showing that we are part of something vast and magnificent. We are, in a very literal sense, children of the cosmos. The iron in our blood, the calcium in our bones, were forged in ancient stars that exploded long before the Earth formed. Our planet coalesced from stardust, and life is the cosmos examining itself with curious eyes. Knowing this, how can we not feel a sense of kinship with the universe at large? Every atom in our bodies has existed since near the beginning of time, cycling through stars and space, and eventually into us. We are linked to the moon that pulls our tides, to the sun that warms us, and to the distant galaxies whose light we barely glimpse. When we send our spacecraft to other planets or listen for signals from the stars, it is the universe, in a way, reaching out to converse with itself. We are both spectators and participants in this grand cosmic drama. Recognizing our place in the universe can fill us with a profound humility, but also great pride. Humility, because we see that our planet is just one of countless others, our star one among billions in our galaxy, and our galaxy one of trillions. The cosmos would carry on just fine without us. And yet pride, because out of this vast stage, we have emerged, beings who can appreciate and reflect on the beauty and mystery around us. In all the expanse of space, as far as we know, we are the only ones who can contemplate the cosmos, at least until we find others. That makes our existence both precious and possibly significant. If we are alone, we bear the responsibility of carrying the flame of consciousness and life forward. If we are not alone, then we have the privilege of joining a greater community of minds. Either way, the cosmic perspective urges us to take care of our home and each other. When seen from space, Earth has no borders. It's a single, delicate world. Our petty quarrels and divisions fade in importance compared to the task of preserving our planet and venturing outward safely. The challenges that seemed insurmountable on a local scale might be addressed more wisely when we think as a planetary species. No matter how many worlds we colonize in the future, or how many neighbors we befriend, Earth will always be our first home, the cradle of our species, deserving of our love and protection. Perhaps the silent stars remind us that we have each other. And for now, that must be enough. It is more than enough. Our journey through space and speculation, from imagining colonies on distant worlds to contemplating alien civilizations, ultimately brings us back to a simple truth. We are a way for the universe to know itself. Whether we find others, or simply carry our own civilization to the stars, our destiny is intertwined with the cosmos. Every child peering up at the night sky, every scientist tuning a radio telescope, every astronaut venturing beyond Earth is participating in an ancient, endless quest to find meaning and connection in a vast and mysterious universe. That quest has driven us to invent, to explore, and to hope. Standing under the stars on a clear night, one cannot help but feel a gentle insignificance and a grand connectedness at the same time. We feel small, yes, but also part of something immense. The atoms in our bodies were born in stars, and perhaps one day our thoughts and creations will drift among those stars as well. In that sense, we are already at home in the cosmos. We always have been. The future might see us build cities on other planets, or exchange greetings with beings from distant suns. But whatever happens, we will carry with us the awareness that we discovered in this remarkable time, that the universe is knowable, and that we have a place within it. In the end, the search for space colonies and alien encounters is really a search for ourselves, for our limits to be pushed, for our hearts and minds to grow, to meet the scale of the cosmos. As we cast our eyes upward and venture outward, we are rewarded not only with new horizons, but with new understanding. Our place in the universe is not central, but it is unique and precious, and it is whatever we choose to make of it. We are the explorers, the listeners, the storytellers of the cosmic tale. The night sky invites us onward with a quiet, eternal invitation. Let us continue to answer that call with wonder, courage, and humility. The future of the cosmos, and our future among the stars, unfolds before us, an endless journey of discovery and hope. And as we step forward into that vast frontier, we carry with us the simple truth that has echoed through this journey, that in seeking to know the cosmos, we come to know ourselves. Under the infinite stars, we are home.